are going to revisit the define, measure, analyze, improve, and control again in the next week. And by diving deeper in some of the tools we already learned, which are very, very important from your implementation point of view, as well as we'll also be learning some additional tools in every phase. In define phase, like the Kano model, quality function deployment. Similarly, in the measure phase, like similar to CP and CPK, we have one more metric, PP and PPK.
Okay.
So what's the difference and when to use what? And similarly, like the gauge R&R, we only understood the situation of repeatability error and then reproducibility error. But how to exactly measure them, how to exactly quantify them and verify for ourselves that the error is lesser than 10%. Similarly, in the analyze space, there are different kinds of hypothesis testing. And in the first part, you will be mastering only a kind of hypothesis testing known as test, we call it test of mean or test of averages. Why test of average is very important? Because most of the time we use the statistics average for decision making. So we will be using the test of averages in the first. But then there are many other hypothesis testing. There are tests for proportion. There are tests for variance. There are tests for relationship. There are tests for checking the normality. There are tests for median. But majority of the situation you will be able to handle just by conducting the test of averages. So that's why we are going to learn that one first. So before we could proceed with the test of averages, so I would like to get your doubts clarified. If you have any doubts, because yesterday's basics is very, very important with respect to hypothesis testing. So you can ask some questions and certainly we will be able to clarify. Or otherwise, me and RK will ask some questions to check whether you people have learned well. So any doubts on yesterday's learning? Come on. Any questions? No questions? Everything is perfect?
Yes, sir.
So why there is a silence? And then
please give one glance.
Forgotten your best practices.
Just give one glance at basic touch up. Just
so 1 minute.
Maybe like Q&A.
That is an audio issue. So can one of you tell me what's the difference between, or first of all, what is hypothesis testing?
Everything.
While joining the meeting, right? Whether you go for a short tea break, we want to know whether you come back or not, right? So yesterday we closed meeting and we are starting with the same closed condition. No, let's have a positive vibe in the morning. So yeah, now one of you, can you define what is hypothesis testing?
Statistical procedure to claim any statement. That is the hypothesis.
Procedure to
claim any statement. Means what statement we have.
It's not a procedure to claim.
Sir, basically it is a validation of a claim to be truth or not.
Very good. Now I agree. It is basically validation of a claim, or you would have told it's a decision-making procedure.
Yes.
Right? Decision-making procedure about a claim. Claim, can be suspecting anything. Your suspicion can be.
Sir, can I come?
Oh yes.
Please note, in fact, I just wanted to be very perfect. It's not that I'm also not perfect. Shiva Sakaran, you made one statement, one word you used to be true. No, I would rather say
truth or
significant.
Yes, right, sir.
That is
correct.
Because truth has to be verified later only. Only
right,
significant we go for the truth. Thank you.
Sure, sir. Thank you,
sir. Correct. Ultimately, after the hypothesis testing is done, once you are able to validate, you are allowed to use the word significant. Till then, you are not supposed to use the word significant. If I ask you, is there a difference? You can always say, yes, there is a difference. But in order to say, yes, there is a significant difference, you must have some data evidence, right? We conduct the experiment only to use the word significant. There is a significant difference in the result after optimizing a particular factor. That means that factor is nothing but your root cause, a critical factor in the current scenario. That's why when you optimize that, your y variable is improving significantly. So that is hypothesis testing. Now, what is null hypothesis? When can you call a hypothesis as null hypothesis? Or what is the identity for null hypothesis?
There
It is equal
Very good. It is a statement of equality.
Equivalent.
with no changes. With no changes.
No changes.
When the claim tells you there is no change or impact.
Yeah,
Yes.
there is no change, there is no difference, there is no impact or equality. Before, after, it is same. When you say like that, then it is null. In hypothesis testing, are we taking decision on the null or on the alternate?
Null.
Null.
Decision is
We are
taken on null.
only first verifying the null. Of course, we really want to know use the alternate, because the experts are telling that you do this, then there will be an impact. But before doing that, I want to understand the significance of the factor. Then whether it gives improvement, what amount of improvement, that comes later. But in order to understand the significance, we first wanted to prove that the statement null is wrong. If null is wrong, null is false, we reject it. And then we will start working on alternate, right? So our decision on hypothesis testing is only on the null. What are the two possibilities finally? Either we reject the null or
Fail to reject it.
fail to reject the null. We reject the null or fail to reject the null. If you fail to reject the null, what are you supposed to do?
Continue the process.
You're supposed not to use your experimental finding.
Right, not to use.
You should, if you are not able to reject the null, fail to reject the null, still you believe in the experiment and try to do something. Please understand, the chances of you making unnecessary changes in the work environment will be very high, which you are not supposed to. Because
Like
always the industry, always the industry practice is only 5%. This is called a level of significance or alpha risk. Alpha risk is permissible. Alpha risk is always 5%. Whenever you realize the alpha risk, involved in your action is more than 5%, it is better to avoid, right? It's a very good leadership quality, right? So when any decision you take, yes, that should be, a really a decision acceptable by at least 95% of the people. This is what we call it, 95% confidence, right? So for that purpose, we always measure alpha risk while taking any decision, even with the help of the data, right? So that is one thing. So whenever we reject the null, that means, we can make changes, right? Assume because the risk involved is 5%. Whenever we are not able to reject the null, then we don't make any changes. We'll simply consider that the factor is not critical. Right? Factor is not critical, and we leave that factor and then start working with next factor, because we are only doing a kind of screening now. You need to understand. In hypothesis testing, we are only doing a screening. There are 20 factors. We don't know which factor is really critical. So one by one, we are screening, right? So it is a preliminary experiment only. You can always do a detailed experiment. Then your approach will be called as design of experiments. That you will be learning next week. Right? That you will be learning next week, because certain things you can understand only if you study the factors together, not one by one. If you study the factor one by one, then you come to certain understanding. But if you study the factors simultaneously, then the understanding will be altogether completely different. If you really wanted to understand, the certain effects which are invisible while doing the hypothesis testing, then you must learn a design of experiments, which will be happening next week, right? And that is one thing. So we understood null and alternate. And then what is that type 1 error in hypothesis testing? Rejecting
Rejecting the true Null
Accepting the good quality.
fail to accept the good quality.
Sorry.
What is
Fail
type
to
1? Type 1 error happens only only when you reject.
reject
Okay.
the true
Good.
null hypothesis.
True.
Null
Huh.
hypothesis.
Null hypothesis is true, still we reject.
Null hypothesis is true, still we reject. Then it is known as type 1 error. Right? Type 1 error. And what is type 2 error?
Accepting the false null.
Null hypothesis is false, you still accept, that is called type 2 error. If type 1 error is 5%, what is your confidence level?
95%.
95.
95%. If type 2 error is 10%, how much is your power of the test? Type 2 error is 10%, then how much is your power of the test?
90%.
90%. That means there is a
90%.
relationship we are seeing here between type 1 error or level of significance and the confidence level. Similarly, type 2 error or beta risk and the power of the test. By the way, what is power of test?
Null is false and we are actually rejecting it.
Rejecting a false null hypothesis correctly. That is known as power of the test. Then what is our definition on confidence level?
Null is true and we are really accepting it. Actually accepting it.
Accepting a true null hypothesis. Very good. So this has to be, in your understanding always while conducting any hypothesis testing. And then we studied about the decision making rule. What is the decision making rule in hypothesis testing? We decide based on the amount of type 1 error we may commit while making the decision, isn't it? If the amount of type 1 error we make is found to be lesser than 5%, we take decision. And the decision is we reject the null. If the amount of type 1 error is estimated to be more than 5%,
Fail to reject that.
we hold the decision. That is what is known as fail to reject the null. So how do we know how much is the amount of type 1 error involved in our decision? We have a tool for that. What is the name of the tool I told you yesterday?
Calculating p-value.
P-value, which means probability of significance. Everything that is happening in this world, there is a chance for it. We can't say this cannot happen. So the events can happen by two means. One is sometimes it happens on its own. Sometimes it happens with a reason. Am I right?
Yes.
If you write the exam and do the hinky-panky and still get a pass mark, it happened for no reason. Right? This is called random chance. This is called random chance. What is the probability for an event to happen randomly? That probability is known as probability of significance. Do you understand? The probability of your data getting generated randomly, there is no reason behind, but still your data can show significance. Right? Actually, there may not be significant, but still your data can show. So you may go wrong in such a situation. But we are measuring that percentage. Because yesterday what we understood is p-value is the risk of observing, or not risk of, p-value is the probability of observing our statistics outside the confidence limit. Isn't it? This definition I have not given in the slides also. You may find it, you may not find it probably in the literature also, because I have never read it.
Sir, can you please repeat, sir?
Yeah, but based on experience, I just understood, so I'm sharing with you. P-value is the probability of observing our statistics outside the confidence limit. Now tell me, what is the meaning of it? Probability of observing the statistics outside the confidence limit?
That 5%, we have to find that.
Very good, only 5%, right? So I have taken a whiteboard here. So here is my statistics. Here is my upper confidence limit. Here is my lower confidence limit. My statistics can fall anywhere here, right? This is the, target or the observed value. This is upper confidence limit. And this is lower confidence limit. 95% of the time, my statistics will be in this region only. Am I right? Or
Yes,
there is
sir.
95% chance that my statistics, it can be average. My statistics can be inside the confidence limit. But still, even if the process is going on normally, still there is a 5% chance that my statistics can come out here, isn't it? So this is what we call it, the 5%. We call it the alpha. And we measure this. When you measure it with the help of the data, we call it p-value. And if the p-value is found to be more than alpha, if p-value is found to be more than alpha, that means, your statistics is still inside only. Your statistics is still inside. But if the p-value, calculated p-value, if it is found to be lesser than alpha, it is very clear it has came out, isn't it? Because what is the probability for your statistics to come out of the confidence limit? 5%.
5% greater than 5%.
But now when you actually estimate that, probability of the event you happened, if that is found to be lesser than 5%, that means your statistics, because when your statistics comes here exactly, now the outside area is 5%. 2.5 on the right, 2.5 on the left. But if it comes little outside, now the probability can drop further. Yes or no? See here, I have a bell curve. All right. If let's say up to this, the area is 95%. Up to this, the area is 95%. So what is this line? This line is line of significance. This area is 95, right? This area is 95%. So what is this area then? 5%. Am I right? All right. Now, when my statistics average is here, what is the area to the right of my average? The area to the right of my average will be 50%, isn't it? Because now I am seeing my average at the center. At the center means the complete area to the right side of the center is 50%. Yes or no?
45 plus 5.
Yes, 45 plus 5. Very good. Suppose if it slightly comes further, do you think you will still have the area to the right side of your average to be 50%, or now it will be less than 50%?
Less than 50.
Less than 50%. As it moves slightly, away from the targeted value, the probability to the area to the right of your statistics will gradually decrease. When it comes exactly to the line of significance, what will be the area to the right side? Come on, tell me.
5%.
What will be the area to the right side of your statistics is now here, exactly at the line of significance. Let's say now you are seeing it exactly at the line of significance. Now, what is the area to the right side of your statistics?
5%.
5%. If it further comes out, the area will go below 5%, isn't it?
Yes.
That is why whenever we understand p-value, whenever we see p-value lesser than alpha, you can make a conclusion that your statistics has crossed the line of significance. Clear? That means the factor has pushed your statistics outside the confidence limit. Right? So just to understand whether our statistics has crossed the line of significance or not, we measure the area from infinity. From infinity, we measure this area. This is 5%. We measure it from the opposite side. When we measure it, that time we realize it is not 5%, it is only 4%. That means your statistics has exceeded the line of significance by this much amount, isn't it?
Yes, sir. This we call it which kind of hypothesis, sir? Null hypothesis, sir?
No. See, in null hypothesis, alternate hypothesis, our understanding is very clear. But now, decision-making procedure is based on p-value.
Okay.
If p-value is less than 0.05, we reject the null.
Reject the null.
Why are we rejecting null? I am just helping you to understand. Because p-value, the meaning of p-value is the area between your statistics and the infinity point. If that area, if that value is lesser than 5%, that's a rare event. Maybe you do some self-study, then only you will be able to better understand. But one thing you can easily understand is your statistics is pushed outside the confidence limit. Can you understand that?
Yes.
Yes.
Correct.
So only when your statistics is pushed outside the confidence limit, then the p-value will go below 5%, right? So that's the thing.
Sir, it's 5% on either side, sir.
Yeah.
No,
Both
2%, 2.5%.
Then it will be 2.5% only, na, sir? Because 95 plus
See,
2.5.
you
Yeah,
are
2.5% on either side.
say in a one-tailed test, it will be 5% on one side. In a two-tailed test, it will get divided equally.
Equally. Yes.
2.5 this side, 2.5 this side, right? In left-tailed test, then your p-value will appear only on the left side. In a right-tailed test, p-value will appear only on the right side. So you have to spend some time on your own to grab certain basics. It is because of the absence of the basics, you are finding here little difficulty, right? If you are comfortable with the terminology, then whatever I speak, you should definitely be able to understand, right? In that way only, I have simplified the concept. So if needed, please go through. A lot of videos, even myself have directly posted in my channel. You can refer that also. Even about p-value, I have posted a video. You can watch that. All right. So any other point? If you want, you can ask. Otherwise, we can proceed.
Yeah, can anyone
Can
summarize
proceed.
what has been learned in 0.23 lines? Can anyone summarize? It'll be nice, no? Because it'll give us some happiness that you have learned something. At least one, because peer learning is always possible then. Otherwise, peer learning also is difficult, no?
If you repeat
Just
something,
come
if you
forward.
repeat something you heard from other person, then the other person can understand that you have listened carefully. Correct? Listening is very, very important skill.
What? Give me some topic, title for this talk. Whatever we have discussed so far, give me an apt title for that.
Validating the potential factor.
Validating the potential.
Evaluating the potential factor.
Evaluating the potential. Have you really evaluated the potential factor? No, right?
No.
Validating.
No, we have not validated anything so far, no? We have not discussed anything about validating. We did not discuss any hypothesis testing. Okay, very good, very good. But any other better than that? Just one word, no? One word.
In
two
hypothesis testing, we take decisions on null, based on null.
Okay, anyway, it doesn't matter. You are trying to make an attempt. Then now tell me, what have you learned now? Tell me, what have you learned in this? What is p-value you have learned? Yes or no?
Yes.
What is a hypothesis? Yes or no?
Yes, sir.
Yes.
Yes.
And what is a hypothesis testing for? It is for decision making. Yes or no?
Yes.
Sir.
And
Yes,
all
sir.
these things, I have just what and all you said yes. Then what is that you have to tell? It doesn't matter. I will tell that same thing. P-value is used for decision making. Yes or no?
Yes, sir. Yes, sir.
P-value
Yes.
is used for making a conclusion. Yes or no?
Yes.
Sir.
And there is a small difference between decision rule and conclusion. I will tell you now, right? Decision rule is if p-value is less than 0.05, reject the null. If p-value is greater than 0.05, fail to reject the null. Yes or no? So you have learned, the title, I would say that p-value. That's all. P-value. You have learned what is p-value. You have explained very clearly excellently the p-value. What is p-value? P-value is used for decision making. Whatever be the type of hypothesis testing, we will teach you 25 tests probably. There are hundreds of hypothesis testing. In all the hundreds of hypothesis testing, we follow the same rule. What is that rule? P-value less than alpha. Alpha is fixed beforehand. Alpha can be fixed two values, but alpha will fix only one value, that is 0.05. Okay. So all the hundreds of tests that you can think of, if it is hypothesis testing, what you check for? P-value. And if the p-value is less, reject the null. If p-value is more, tell me.
Fail to
Fail
reject
to
the
reject the null.
Fail to reject
then
the.
this is how that a mother is patting on the child and then promoting the child's enthusiasm. You are not doing. You are my parent now. Actually, no. Beyond an age, become children. No, we have to crawl only. I can't even walk now. Right? Please do that. Right? My request. Right? Okay. Very good. Understood.
All right.
Then what is the conclusion? If p-value is low, what is the conclusion? What is the conclusion? The alternative statement is
Out of confidence limit and
the alternate
expectation.
statement. No, alternative statement. That is a statement, yeah.
Yeah, statement is
I will
significant.
tell you one thing. RK is good. RK is good, hypothesis statement. Null hypothesis statement. Now you have found that p-value is less than 0.05. Now what do? You have to reject the null. What is the null? RK is good. So what is the conclusion? Tell me,
RK is too good.
RK is too good.
Yeah, very good. Now you have to check that. That means what he says is right, no? It is significant. It is not so significant, you have to check. That's all. You still have to do some experiment because we found that it is not good there. But it is only significant. We have to prove that. So we may end up in Ashok Kumar's statement correct, right? Oh, yes, that is a chance purely by chance. Thank you very much.
Yeah.
You can make a
All right.
conclusion. Bye.
Great. So now that you have a clarity, the decision is based on p-value
P-value.
0.05, then you reject the null. More than 0.05, fail to reject the null. Let's use this in a real-time scenario. I'll be teaching one sample G-test, one sample T-test, and then two sample T-test. Then RK will teach you one-way ANOVA. That's all. Then the further deeper learning will happen at the next level. And for the next level, this foundation is required. Without the foundation, learning having the discussion at the next level will be very challenging for you, right? And that's why next week is the most appropriate time for all of you. Don't miss it. All right. So here, I suggest don't read this question. I'll tell you why, right? So let me straight away go here. So let me explain the scenario. Yesterday, I told you, right? Fat content, right? Saturated fat content. So the fat content, a company is manufacturing cooking oil and they claim that the fat content is 15%. Fat content is a continuous data. Am I right? Fat content is continuous data. Am I correct or not?
Yes, sir. That is
Okay.
Yes, sir.
measurable. Yes.
Yeah. Fat content is continuous data. 1 minute. I'm just making that change. It can be 15 minutes. See, why I have typed it differently is, ultimately, you should know that you are only working with data. Data can represent any scenario, right? See here the same problem. I can explain in two ways. One is for a manufacturing context. In manufacturing context, it is a product. It is a product and the metric is fat content. The same thing, same test in the service industry will be with some other metric, isn't it? Transaction time. Am I right? So transaction time is in CTQ, maybe in a service related scenario. So it can represent the transaction time or it can represent fat content, but in both cases it is continuous data, right? Now let us talk in terms of fat content. So the fat content printed by the company is 15%. Now you want to check. So what do you do normally? You take sample. See here you have taken some sample. How many sample you have taken? You can count. How many samples are here?
13, sir.
13. So 13 is your sample size. You have
13.
taken 13 sample and that is written here also. Sample size 13. Population mean. The company claim that the product have 15% fat content. That is population mean. But your sample mean is how much? 16.6. Now you are a little confused. Since 16.6 is different from 15, but seem to be closer to 15, isn't it? Now what should I decide? Should I decide that this difference is insignificant? Insignificant means I can still recommend it. But is this difference just 1.6? Is it really significant? Isn't it? Because we don't know. The difference of 1.6 in the context of fat content, we don't know whether it is too big or too less. Am I correct or not?
Yes, sir.
In an examination, in the black belt exam, if two students have a score difference of just 1.6, I don't see it, a big difference. It's not significant. Am I right? But if
Yes,
you are
sir.
writing for a, let's say, a public service examination, there a difference of 1.6 is very
Yes.
significant.
Yes.
You may even lose a job, right? So the
Yes.
situation has to tell us whether it is significant or not. So this is what we are actually testing. If you want to know whether a difference is there or not, you don't require any hypothesis testing. Looking at the number, you decide. Everybody knows 16.6 is higher than 15. But what we want to know is this difference is due to a special reason, due to the failure of the process, or due to certain factor malfunctioning, or is it happening randomly? If it is happening randomly, you don't have to worry. The next batch will have proper spec. If it happens for a reason, then it will keep continuing. So that is what you want to predict, right? So we go for hypothesis testing. Now population standard deviation. Sometimes the company will share the population standard deviation with you. Even though you are working in the company for last 5-10 years, they don't share all the details. Isn't it? Sometimes they share, but many times they don't share. That means in this case, population standard deviation is revealed to you. Over and above, you can calculate sample standard deviation. Why we need sample standard deviation? Whenever population standard deviation is not available, you can use the sample standard deviation in that place. Whenever breakfast is not prepared, you can order from Swiggy or Zomato. Similarly, whenever population standard deviation is not available, in that context only you can use sample standard deviation. We know outside food is not healthier, but still what to do? We have to have breakfast. Same manner, using sample standard deviation is less accurate prediction, but using population standard deviation is more accurate. If you use population standard deviation, your test will be called one sample G test. If you use sample standard deviation, then your test will be called one sample T test. Now you understand the difference, right? Z test and T test. When will you go for Z test? When population standard deviation is revealed to you, known to you. If it is unknown, you go for one sample T test. Now let us do one sample G test first. In order to conduct the G test, you must calculate G score. You remember already I taught you G score. What is G score? The
Number of standard deviation.
The distance of your statistics from the center. How much distance your statistics moved from the center? Please note. One second, I'll take a pen. See here. You have the bell curve. What is that we are studying? We are studying how is our average is moving, right? How is our average is moving? That means every point on the curve is an average. Please note. Every point on the curve is an average. This can be your first average, sample average, nothing but sample average. This is your second average. Likewise, so many averages, etc., etc. Now the center point is nothing but average of the averages. Am I right? Center point is X double bar. If my X double bar appear in the center, I have no issues. But if I take an average, if I take a sample and my average appears here, I understand my average is now shifted to the right side. Correct? So this distance of your average from the center of the distribution is nothing but Z score. The Z score at the center will be 0. Why Z score at the center is 0? Because your average is exactly on the center of the distribution. There is no movement. Can you understand? Imagine you are supposed to produce a product with a diameter of 100 plus or minus 0.5. Now, what is the target? 100.
100.
And now you are taking a sample and the sample average is also found to be 100. Now your process has not moved from the center, isn't it? Your process center is exactly on the target. Am I right or not?
Yes, sir.
This is the target which customer wanted, 100. I have taken a sample and that sample average also 100. The customer target is mu. Sample average is 100. Now I calculate Z score using a formula. X bar minus mu divided by a factor called standard error of the mean. What is that factor? Standard error of the mean. Now, what is your X bar? 100. What is your mu? That is also 100. So what will be your resulting Z score? 0. Am I right? Your Z score is 0 here. If the Z score keeps moving, if the statistics, your average keeps moving to the right side, what will happen to your Z score? It will keep increasing. Am I right?
Yes.
I am only checking whether by knowing my Z score, I am only checking whether my statistics is going beyond the line of significance or not. Whether it is going beyond the line of significance or not, right? So if it goes beyond the line of significance, then my Z score will be crossing a specified value. So that's what we are checking. 1 minute. So I'm erasing this. So these calculations will be little tough, but that will become simple if you put some extra efforts and then attend the coming Thursday class and then subsequent week, right? So let me straight away use the formula here. See here, sample average is 16.6. Am I right here? Because the formula says X bar minus mu divided by sigma X bar. The sigma X bar is known as standard error of the mean. Sigma X bar is known as standard error of the mean. And how to find out the standard error of the mean? Population standard deviation divided by square root of n. I substitute all the value. N is 13. Population standard deviation 2.6. Now what is the G score I am getting? 2.2. But in a two-tailed study, please note, in a two-tailed study means you don't want to see your statistics either going to the extreme right or going to the extreme left. Both are problematic for you. You want your fat content to always stay around 15. Left side also you don't want to recommend, right side also you don't want to recommend. Under such condition, your Z score, maximum permissible Z score is 1.645. But how much is the calculated value? 2.2. 2.2 is more than 1.645. You reject the null. This is, please note, this is the method followed 10-15 years before. Nowadays, nobody is using this method because computers have come. Softwares are developed. These softwares will do all the calculation and simply convert these values into a p-value. Software will convert all the data into p-value. So let me show you. Let me show you the Minitab report. When I feed all the value, can you see the 2.22 here? The 2.22 is converted into p-value. How much is your p-value here?
0.013.
0.013. The 0.013 is the p-value. Now the p-value is 0.013. Is it less than 0.05 or more than 0.05?
Less than
Less than 0.05. If it is less than 0.05, what is your decision?
Reject the null.
Reject the null. So what is your null here? Look at your null here.
Null is exactly 15.
Fat content is equal to 15%. That is your null. But what is the data is our experiment is confirming? It is not 15%. That means the distance is now considered significant. Under such situation, it is better not to recommend this cooking oil to your friends and relatives. Don't do that. The company is, simply, cheating. They are saying that it is the fat content is 15%, but the fat content measured is abnormally high. It's not high. It is abnormally high. If something is abnormally high, you don't have to believe the statement. Am I right? So this is that's the meaning of significance. The fat content is significantly higher than the declared value. So I am not going to believe the company and use the fat content. If I believe, and one day they may even give me, cooking oil with much more higher fat content. I don't want to believe. Do you understand the meaning? All right. So this is called one sample G test. So now what we are going to do is, let us do this test in Minitab, right? So in order to do it in Minitab, let me share my screen. Share my complete screen so that you can see what am I doing. So first thing is we need the data. So those of you who want to do parallelly, you can also try. So first thing is we need the data. Data I have given in the sigma level calculator. I'm opening it for you. See, if you understand, you can handle any scenario. Fat content. Cooking oil, fat content. Here is the data. I just copy. I just copy the 13 data. Now I have to open the Minitab. I'm just opening it.
Kusal. Kusal? Hey, Kusal.
Yes, sir. What happened?
Some noise. It's opening. Once you start using Minitab, then all the procedure is taken care. Parallelly, you can master. So I'm just copying this data here. And what is this? Fat content, right? Now tell me, fat content, we all know it is continuous data, right? Yes or no? It is continuous data. If it is continuous data, then you need to calculate average for decision making. You look at the average and take decision. Now what is the recommended test here? The recommended test is a kind of test of average. Am I right? And which test we can go for right now? One sample G test. Why I am choosing one sample G test? Because the population
Standard deviation given.
Population standard deviation is known. That is the reason. So now null hypothesis. What is your null hypothesis? You can believe the company statement. Fat content equal to 15% means null. What is your alternate?
More or less than.
More or less
Fat,
than.
fat content not equal to 15%. There are other options. You can say more than 15%. Then it becomes right tail. There is one more option. You can say less than 15%. Then it becomes left tail. But right now, it is a two-tailed test. Because it is for the two-tailed test, the permissible z-score is 1.645. If it is a one-tailed test, then the permissible z-score is 1.96. You have to spend a little time to understand all of this, right? That will happen slightly at the next level. But even though you don't know the g-score, you can still take a decision by referring to the p-value, right? But now the g-score, anyway, reference value I have given. Now, in order to calculate the g-score, the formula is difference in the mean divided by standard error of the mean. What is the formula? Difference in the mean divided by standard error of the mean. So this is what is written as x bar minus mu divided by sigma by root n, isn't it? Am I correct? Sigma by root n, square root of n. So if you do these things repeatedly, then you definitely come to know. Or I can say SQRT, square root of n, where n is sample size. This is the formula. So in Minitab, you don't have to do all of this. We have done it already manually. See here, go to stat, go to basic stat. Can you see one sample g-test? Can one of you
Sir.
read out the description? Read out the description.
Whether the mean of a sample differs significantly from a specified value when the population standard deviation is known.
We are following it perfectly. We are choosing the right hypothesis testing. So I click that. Now, one or more sample in a column, summary of the data. We have the raw data only. Choose the sample in a column, click here. Now, which column contains your data? C1. Click and select. What is the known standard deviation? Population standard deviation. It is given as 2.6. It is given as 2.6. Perform hypothesis test. What is the hypothesized mean? What is the hypothesized fat content? 15%.
Equal to 15. Okay.
Now go to option. Confidence level, 95%. You want to make it two-tailed or you want to make it one-tailed? You want to make it right tail or left tail? You can choose. But you should know, if you make it two-tailed, the maximum G-score allowed is
1.645.
1.645. For two-tailed, it is
1.9.
1.96. So now it is 1.645.
1.96. Correct. 2 times 1.645.
Okay. So when I make it two-tailed, that score should be more. Wait. What? I might have done some mistake. Okay. Sorry, I made a small mistake. For two-tailed, it is 1.96. For one-tailed, it is 1.645. So there is a small mistake. So for two-tailed, it is 1.96. For one-tailed, it is 1.645. Let us do it. Stat, basic stat, one sample t-test, and column 1, and it is 2.6. Perform the hypothesis test. Tick here, and then put 15 here. Option 95%. I make it two-tailed. That means permissible is 1.96. Okay, and then one more okay. Now the complete hypothesis testing is done. You have got to know the G-score of 2.22. That means it is more than 1.96. Alternatively, the p-value is found to be lesser than 0.05. Can you see? You do any one. P-value lesser than 0.05. If p-value is lesser than 0.05, you have to reject the null.
Reject the null.
Reject the null means what?
Accept the alternator.
Fat content is
Incorrect. Not considered the condition.
not equal to 15%. It is significantly significantly different from 15%. Under such a conclusion, do you really want to use this cooking oil for your family or for your friends, or do you want to recommend to your clients?
No.
Why you should take unnecessary risk, right? So you can't consider this deviation as a random one. This is a significant one. That is why you rejected the null. So practical conclusion. What is the practical conclusion? Don't recommend this cooking oil brand. Am I right? Now you are able to take decision. The statistically saying reject null hypothesis, these are all okay. But finally, this is what is required.
So, sir, in this condition, we are not recommending because it is different from 15%. It may be good or it may bad also. We don't know.
Yeah. See, a bank has told you they'll give, they'll give a particular interest if you deposit the money. But reality, they pay interest lower than that. Saying, they say many reasons. But now looking at the difference, you understand, you are now doubting whether it is, acceptable or it is, they are, it is significantly lower. So for that, you can actually use the same thing. And then based on that, if it is very marginal, nothing wrong in referring, others also to deposit the money in the bank. But if it is significantly lower, what will happen? And if somebody is depositing the money the same manner, then they may say that, the entire, even the principal is also lost. It's possible. So that means the difference is significant. It is better not to recommend this product. That is the idea. Now let us do the same thing in a one-tailed test manner. One-tailed means the only difference is null is fat content is equal to 15%. Now alternate will be, that is your H1. H1 will be fat content is higher than 15%. Do you understand? Fat content is now higher than 15%.
Higher than 15%.
Yeah. In this case, okay, let's do it. Stat, basic stat, basic stat, one sample G test. Everything is written. Now the only difference is here I have to make change. I should make it right tail, right? Because I'm only interested in checking whether it is significantly higher. So I do that and then I give okay. Now, can you see your p-value now? What is your p-value?
0.0313.
P-value is lesser than 0.05. So what should you do? Here also you have to reject the null. You know the meaning of rejecting the null, isn't it? Do you know the meaning of rejecting the null? Come on, what is the meaning?
Fat content is more than
Fat content
15%.
is more than. It is better, not to believe whatever the company is saying. Don't believe. That's the practical conclusion. Now, for the same scenario, if standard deviation is unknown, then I will go for one sample t test. Let me do it. Stat. Okay. Stat, basic stat. Can you see one sample t test? The description
Yes.
goes like this. Determine whether the mean of a sample differs significantly from a specified value. Nothing known about population standard deviation. Now, one or more sample in a column and the column is fat content. Hypothesis testing is 15%. And now I go to option. And here also, let me make it one tail. Now we will use a statistics known as t-score. But don't worry about all these statistics, G-score, T-score, F-score, chi-square score, so many things. You don't have to worry. Slowly you can master because all of these can be converted into p-value. Now our conclusion becomes easier. So I give okay. Now what is the p-value again?
0.0.
Not 8.
Again less than 0.05. Same conclusion.
Reject the
reject the null. So this is how you need to conduct one sample test. I have explained two things. One is one sample G test and then one sample T test. RK sir? RK sir?
Yes, I am coming.
Yeah. So maybe just give me 10 minutes here. I'll again join.
Okay.
So I have just done with one sample G test and then T test. So participants, have you understood how we performed it? In G test, we calculated a statistics called G score. In T test, we calculated T score. But you don't break your head to understand what is, how to calculate G and T. Because both can be converted into P value.
Value.
We'll give this job initially to Minitab or some software. Even Excel also can generate. But slowly you can understand what's happening behind P value. You can learn. Definitely the more clarity will come only in the next round of learning, not straight away. Right? So we'll make it crystal clear probably next week. Yes, RK sir. So the 2 sample T test.
Yeah.
I have to cover, but anyway, I need a 10 minutes break here. A guest has come. I'll just come.
So
Okay, sir.
Break time, right?
Just 10 minutes.
Please go for break, no? Come back fresh.
Okay.
Okay. So have you understood the one sample G test and then one sample T test here? Very clear? Come on, all of you. You can't learn hypothesis testing in this manner. This is something, very critical tool. You have to deep dive and then master it. Then only your, the belt will start working in your career. So this it is exactly this particular tool you need to master, right? So G test and then T test. Now let us proceed to 2 sample T test.
Yes, sir.
Okay.
So I'll cover, sir, two sample T test also I'll cover, and then you can teach another. All
So
right.
you're going to take, huh?
Yeah, I have come back. I will take, suddenly, a guest has come. So I don't know what to do. That's why I have to leave abruptly. Anyway, not a problem. So we have done this one sample T test, and now, so all the calculations are also explained. You can refer in the material. But however, I suggest you don't worry about the calculations here. Try to generate the P value. If you can get the P value, see here, you take the decision. But statistical decision is rejecting the null or fail to reject the null. Practical decision, you use your common sense, what to do. Right? Use your common sense. If something is significantly different, it is better not to believe and then proceed. So take a practical decision. See, now here there is a bank. The bank has come up with an offer for their credit card. They have given an offer for their credit card. Now they want to know whether the offer is really boosting the sales or not. Do you understand what context and hypothesis is getting built here? The bank is giving an offer for a particular period. Use this card, special card, and you get a lot of extra benefits, extra discount, lower interest rate. Is this offer can really boost to the sales? Now, what is your output here? Output is sales, right? So sales is your Y variable. For sales means purchase amount. Now tell me, purchase amount is continuous or discrete?
Continuous.
Continuous data.
Continuous.
Measurable.
And now you are comparing two scenarios. One scenario, the standard card. The other scenario, the new card. The new card has added feature. And you want to know whether giving this added feature is really worth. It is considered worth if it can boost the sales. Not just boost the sales, significantly boost the sale, isn't it?
Yes.
That's what. So now the output is Y variable is continuous. There are two groups here. So now the study is known as two-sample t-test. Similar scenario, if you come across, you can also use this same two-sample t-test. You are evaluating two suppliers, or you are evaluating two machines, you are evaluating two departments, or you are comparing two of your team members, or you are comparing two factories, or you are comparing two methods, two materials. All of them are situation for two-sample t-test. For example, today India is facing Sri Lanka in the Asia Cup, right? That is also a
Yes.
hypothesis testing. Do you know
Yes.
what is the null hypothesis? Both teams are equally competent. We can always share the cup, but we don't want to. So we go for experimentation. The teams have decided to play 300 balls. Sample size is 300, isn't it? Indian team play 50 overs, and the Sri Lankan team will also play 50 overs. And in order to make the decision, what is the metric they are using? The runs scored, isn't it? The
Yes.
number of runs. So that is also similar to two-sample t-test. But here, their rule is different. Every game has got a rule, isn't it? If a team can score at least one run more than the other team, then the team is declared winner. Am I right?
Yes.
But our rule is different. Our rule is our statistics has to go beyond the level of significance, or our p-value should go below 5%. But their rule is difference of one run is required minimum. Nothing else. Understand? So the rule has to be understood before playing the game. In hypothesis testing, what is the rule? P-value. P-value lesser than 0.05. The rule is to reject the null. So now it is two-sample t-test. See here, lot of formula, lot of calculation. I don't want you to learn all the calculations straight away. No, use the software. Minitab. Look at the p-value. See here. P-value is less than 0.05 or more than 0.05?
Less than.
Less than 0.05 means the difference is significant. It makes sense to now look into the data. Look into the data now. The average purchase for the new card. How much is the average purchase? $1,637.5. But old card, $1,566. Now the difference, whatever dollars you are seeing, that difference is due to the offer. You can credit that difference to the newly introduced offer. All of you understand? That means addition of certain feature or providing the lowest interest rate is really significantly boosting your sales. Now you can spread this offer across the country. You have studied it in a small branch in a particular sample. Maybe for 500 people you have done this. Now since you have seen that a good result, sales is going up, it is really significant. You can spread this offer in all your branches across the country. That is the final conclusion. See here, p-value is generated, so unequal, so we reject the null. That means the difference in the mean, there is a significant difference in the mean purchase. The practical conclusion is the promotion is critical to purchase. The promotion is critical to purchase. So 0.024. So let me do this in Minitab also for you. So this is promotion, right? So every data is available in our Excel file. You can do it. Unless and until you also practice by your own hand, then gaining confidence will be difficult. It might look, a nightmare. So here it is promotion. See here promotion. There are two columns of data. Copy this. See here, so much data they have collected. 250 sample each. Control C. Now you go to Minitab. Maybe somewhere you can paste here. Now, how to conduct? Stat, basic stat, 2 sample T. Now, both sample are in one column. No, they are in different column. So choose the second option. Sample number 1 is in column number 3. Sample number 2 is column number 4. Option. 95% confidence level. Hypothesized difference. There is no difference. So hypothesis difference is 0. Alternate hypothesis is not equal to 0. You can say not equal to 0, or you can make it right tail, you can make it left tail. Now, one important condition for 2 sample t-test is the variance should be equal. You can either assume or you can do a separate hypothesis testing for variance also, right? You can do it little later. Now you assume. You simply assume that the variances are equal. Now you give OK. Now you again give OK. Now the entire hypothesis testing is done. Can you see p-value? Which is less than 0.05. So you reject the null. You rejecting the null means the offer is really working. The offer is boosting the sales significantly. Whenever you see p-value lesser than 0.05, only then you can go and look at your data. Look at your data. You can read. It makes sense. Reading the data only when p-value is lesser than 0.05. When p-value is not lesser than 0.05, you still read the data. You are traveling in a risky direction. All of it, you understand? When to use your findings and when not to use your findings. Tell me, when can you use your experimental findings? Only when p-value is
less than
lesser
0.5.
than 0.05. That's all. Now you understood 1 sample g-test. You understood 1 sample t-test. You also understood 2 sample t-test. All of them are test of averages. If the number of groups you study, if it becomes more than 2, now that it will lead to a new scenario and a new kind of test known as ANOVA, analysis of variance. Now, if you want to get verified where and all this hypothesis testing can be applicable in your domain, then what you can do is you can share your scenario with us, maybe in the group, or you can write to us through WhatsApp or whatever, or you can write now, even if you want, you can put it in the chat box. Then we can suggest what are all the situations that qualify for test of average. What is the condition? What is that we need to check? Data type. What is the requirement? Data type must be
Continuous.
Another thing is average. We calculate average for decision making. If there is only 1 group or 2 group or more than 2 group. Within 1 group, we have 2 categories. One with the population standard deviation known, one with unknown standard deviation. Known standard deviation is 1 sample g-test. Unknown standard deviation is 1 sample
t-test.
If there are 2 groups, it becomes 2 sample t-test.
T-test.
If there are more than 2, let's say 3, 4, 10.
ANOVA.
ANOVA. Why, sir, so many testing? Because we are only getting an estimate. Please note, in statistics, we are only getting an estimate. There is no just single route. There are several routes available. But whichever is the best, that is what we are learning here. They used to start data in a particular manner for decision making. Accordingly, the procedures are named. So the best procedure we are teaching you, and you can also follow. So with this, I hand over the session to RK so that he can teach you ANOVA. All right? Okay?
Thank you very much. Yeah, you have to stop sharing, no?
All right.
So you are all, I think, nice to listen to my talk now. Right?
Yes.
So, ANOVA, what is that you are going to do, ANOVA? What do you want me to teach you in ANOVA? Tell me now. You tell me. What is that you want me to teach you in ANOVA? Just tell some questions so that I will try to answer that. Please note, try to get the habit of asking questions without knowing anything. That is first important thing. Yes or no in life? You don't know anything about ANOVA, I know that.
Yes.
Now you start asking
Yes.
questions to me.
So I have a question, sir.
Yes.
So GSK sir said that if there are 3 or more variables, if you check for more 3 or more variables, then we can use ANOVA. So I am from HR. So if I have to say in a company, if I have to check how many people are eligible for promotions, how many are fall more than the 95%, 90% range to provide
Yes.
the certain, can we
Yes.
use ANOVA for that?
Yes, once again, let me tell you, you can't use any of these things for your science, HR science, these things. Please note that. But anyway, if you have little probably smartness, you can use everything. There are equivalent things. I will also give you templates for that. Definitely, because now that you have asked the question, that is what I am saying. No, only if you ask the question, you will be able to get the answers. Why you will apply along Tamil? I don't know what is in English. Please ask for it, right? But that doesn't mean that you should not listen to this topic this session. You must listen to this topic so that you will know what it is. First of all, you have used a term called variable. I think that we must know what do you mean by variable, right? Please note, I am having your name is Rashmi today. Your name is Rajalashmi tomorrow. Your name is HR head of the department. Your name is vice president day after tomorrow. That means your name is a variable. Yes or no?
Yes.
Right. Now I have got money now in my hand. Hand on cash. Cash on hand. Cash on hand is today 10 rupees. Cash on hand tomorrow is 20 rupees. Cash on hand is 30 rupees the day after. So that variable, this is a variable. Understood? The variable is something which keeps varying. Understood? Clear?
Yes, sir.
So we should not use the variable term there in what you, but I have understood what you are asking, right? Clear? We just want to find out this department is better or that department is better. So that department is that department only. Is it variable? No. The another department is another department only. That is not variable. Clear? Understood? So we are going to use first of all jargons there, terms there. That terms, if you remember, these are all simple terms which you always remember, right? Group we will use, factor we will use, levels we will use. Okay, clear? Groups, levels, treatment, factors, these are all jargons, but simple jargons, right? You will understand later. I will come to it now. So GSK said that you can use it for HR also. We will use it for HR also. But I will tell you, anything you can compare only if you have a metric measure, numbers. Yes or no? Rashmi madam, tell me, yeah?
Yes, sir.
Right? If my middle finger is bigger or the thumb is bigger, you will have to find out the measure is the length of the fingers.
Yes.
So you must have a number, first of all. That is why we say that we have a number called ordinal number. What is the number called? Ordinal number. Ordinal number means we are just giving them a rank. In HR department, we give only ranks, nothing else. Yes or no?
Yes.
If I say that Rashmi is better than RK, how much better, we will not know. Right? Unless otherwise you give a test and then we perform, she performs, find out the mark, and that again is not that is a variable.
Yes.
Tomorrow, if the same test, I will score another higher mark, you will show much higher mark. Yes or no?
Yes.
The difference between me and Rashmi may be 10 today, maybe 25 tomorrow. Right? Therefore, but you still, to find out who is better, better is an attribute.
Yes.
Is good, better is an attribute, right? His performance is good or better is an attribute. How will you compare that? Only by number. So always numbers is very essential. If you know the trick of converting a variable to a number. When I say variable here, I'm using a number, right? That is a real number. Real number varies from minus infinity to plus infinity. Any number, right? That should be converted into a binary number. What do you mean by binary number? 0 or 1. 0 means good, 1 means bad. Sorry, a 0 means bad, 1 means good. A 0 means fail, 1 means pass. Right? This is where the trick comes. If you know that, all the things will be very easy, Rashmi madam, for your HR applications, all these hypothesis tests. But we will definitely spend some 1 week, 1 day, 1 hour, call with your friends, your peer members. We will have 1 day session, 1 hour session, and then we will clarify all your doubts. Okay, ma?
Okay, sir.
Thank you. Now coming back to ANOVA, I said that you asked me what do you want in ANOVA. I will keep on asking the questions on your behalf, right? Sir, tell me what is ANOVA first. Yes or no? And tell me what is the use of ANOVA for me next. Yes or no? Likewise, you ask a few
Yes.
questions here now, please.
Yes, sir.
So when we can use ANOVA, sir, first means?
Where we
Yeah,
can.
first
So when you want to
question
find
from my
out,
side.
when you want to compare groups, when you want to compare more than two groups, when you want to compare two groups also, we can use, that is waste of time. No, if you want to compare more than two groups, we'll do it, right? I can buy and it. See, I tell you, last month I think I went to Woodlands Hotel. I unfortunately, unfortunately, I thought that I'm old man, I should take idli. No, idli costs, you know how much? 2 idlis, you know how much? 188 rupees. Then I thought that I go to my street end, I will get 15 rupees idli. Well, started. Okay? Therefore, you can compare. You can, for comparing more than two groups, you can use this ANOVA. Right? Now tell me, why do you want to compare? Why do you want to compare? You want to take a decision whether I should take this particular item or that particular item or the other particular thing. It's a different name, ANOVA, where it is coming from. Analysis of variance. You know what is variance? Yes or no?
Yes, sir.
Analysis of variance. Variance means square of the deviation. So we are trying to find out the deviation and then check. Right? Now I'll tell you, RK is costing you per hour 100 rupees. And then Shivakumar is also costing you 100 rupees per hour. Then who will select? Who you will select? Do you have any preference over Gopal Shivakumar RK based on the cost only?
No.
No.
You'll have.
Now suppose I am saying is RK will charge 100 rupees, but the variation will be plus or minus 50%. Gopal Shivakumar will be charging you 100 rupees, but the variation will be plus or minus 20%. Right? So now, Rashmi, all the participants, you tell me whom you will select now.
Gopal sir, sir.
Yes, sir.
That's all. What did you use there? The variance.
Variance.
That's all we are using ANOVA. Clear? Understood?
Good.
Yes, sir.
We are not only comparing the mean. If the means are same also, then I'm going to compare the variance and then decide who is better. Or there is no variation. Both are same or both are not same. Understood?
Yes,
This
sir.
one, it is so easy for you to do it just like that by just my telling you, asking you. But if the data are thousands of data, right? Then how you select? You go for ANOVA computer. Why computer? RK has made a template for you. Use the template. You will be able to select it. And then the decision. How will you select? Based on the mean.
Based on the data.
Based on the data. Based on the data, you will find out the mean. RK is costing 150 rupees. And variation also is less, yeah. So we'll go for RK like that, right? Because I like to promote myself also for some time. Thank you very much. So now you got it. What is ANOVA? Why is it used? Where is it used? You want to compare. Now we are going to compare not attributes. We are not going to compare only the variable. Now I am using the term variable because Rashmi has used the term variable. I want to use the term variable in different concepts in different ways. No, variable, I'm using it as a number, real number. That's all. Understand? I'm using comparing a continuous data, they will say. Comparing average, they will say. All are same. All are same, right? You don't say that RK is telling different things. I don't know what he's telling at all. I'm telling the same thing. I'm telling the same thing in different words so that a person who knows Greek also can understand. A person who do not know Greek also can understand. Now you can understand. Have you understood? Have you understood what is ANOVA?
Yes, sir. I have a question.
Yes.
Analysis of
Yes,
variance.
sir.
But what we are doing, we are comparing the averages. We are using the variance to compare the averages and take a decision. Okay? We are using the variance to compare the average. So it is a test of means only. It is not a test of variance. Right? We are using the analysis of variance, that is square of the deviation, to compare the averages. Am I making it clear? In my own corner of my mind, I'm saying that I'm trying to confuse
Yes,
you.
sir.
I'm not confusing you. But,
No. Yes, yes, yes.
the analysis of variance is a cheat, right? So we are comparing the means only, right? So using the term analysis of variance, which is done in the analysis. Clear? Now, suppose I want to hire a particular supplier. There are 3 suppliers. And the 3 suppliers I'm using for some consultancies. And all consultancies, they are giving this time they take is called transaction time. Now you understood the problem? I am getting consultancy from 3 people, right? Shiva, Ashok Kumar, and Manimaran. All the 3 people are giving RK consultancy. Whenever I ask a question, immediately I will ask a road for reaching Chandrakant. They'll say that you go this way, go by train, go by whatever. Some transaction time it takes. And they charge me based on transaction time. So my transaction time should be minimum. Yes or no? Whoever gives me the consultancy, successful consultancy in a short time, I am going to select.
Yes.
Now I am noting down the transaction time. I am doing thousands of transactions, right? I am running thousands of softwares every day. I'm trying to get the answers. Use it, right? Flipkart is using thousands and millions of transactions every day. Now this transaction time I'm taking for 3 groups. The transaction time I'm taking it for 3 treatments. Transaction time I'm taking for 3 different suppliers. All are same. Clear? So depending upon your application, you can use supplier, factor, or variable, or whatever you may use it. You use it even variable, no problem, right? Variable 1, variable 2, variable 3. That's all. Right? Variable 1 is Shiva, variable 2 is Ashok Kumar, variable 3 is Manimara. Whatever. Factor is the best term. Factor we are using. Now, I have taken hundreds of data for Shiva, hundreds of data for Ashok Kumar as supplier, hundreds of data from Manimaran as supplier. Now I am finding out the averages, average transaction time. Right? I'm trying to find out the average transaction time. What I will do normally, the average transaction time for Shiva is 20 minutes. Average transaction time for Ashok Kumar is 22 minutes. Average transaction time for Manimaran is 19 minutes. So 19, 20 and 22 minutes, it's small, very small difference. What you will do, 22 minutes is very best. Ashok Kumar is very best. Ashok Kumar is just, Shiva is very best. Shiva is taking only 19 minutes. So I'll try to place the order on Shiva. Yes or no? Neglecting Ashok Kumar. That day also I neglected Ashok Kumar, I think. No, sorry. No, I keep on neglecting the same person. No, right. Okay. This decision is wrong. This decision is wrong because, why I will tell you, Shiva might have taken average of 19 minutes, but for one easy transaction, I will ask him, what is my name? He will immediately tell, hey, your name is RK. So transaction time required is just 1 second. But for another transaction, he has taken 21, average is 42. So he must have taken 42 seconds. What is the variance? The variation? 40 minutes. Yes or no?
Yes.
I do not know. I will not go for Shiva because sometimes he takes less time, sometimes he takes too much time. I don't bother. But Ashok Kumar, even though he's taking 21 minutes, for all types of my request, he is just taking 20 to 24 minutes. Variation is less. Yes or no?
Yes.
So now I will go for whom?
Ashok.
That's all, Ashok. Right? So this is how you are taking. This is easy for you to do it because I am just giving you one data, but I'm giving you thousands of data. You will have to find out the variation and things like that. Procedures are there. Structural. That is why we go for Six Sigma methodology. What is that? Structure. We'll never make mistakes. Even if we make mistakes, no, we are bound to make mistakes. Even if we make mistakes, no, what is the chance of that mistake?
5%.
Huh?
5%.
Very good. That's all.
5%.
5%. Keep that in mind, right? Why we are having only 5% error?
P value.
Because we are testing it against p value.
No. Remember, go to the basic sigma belt type distribution with mean 0, sigma
90.
1.96. Z is equal to 1.96. Understand? We have taken Z is equal to 1.96. The right hand area is 2.5%. Left hand area is 2.5%. Therefore, right? But we will never use the Z value. Somebody was asking Z is 0 and all. Z value, we will never use it. We are going to use only P value, right? Okay. P value is 0.05. We have fixed. Okay. With this small confusing introduction, let me go to a template. I will give you how to use it. All that you need is data. different groups, number of groups, and each group will have a different number of data. Understood? Understood? Right. Can I go to share the screen? Can I share the screen? How many
Yes.
of you know Excel? Anybody knows Excel?
Yes, sir.
Yes, sir.
Yes. One of you must download it. I will give the template right away. Then you can use it as you like, right? But don't use it right away because you can copy it right away, take it right away. But I'll explain how to use it, then you can take it. So I will just first of all go to my chat box. Where is my chat box? Right. I'll just put my computer. Where is my computer? Is there? I have given you all the ANOVA tests, but you use it only for ANOVA. It's a different name, ANOVA, where it's coming from. Now that's all over. Right. Okay. Okay. Now, are you able to see my screen? Yes or no?
Yes, yes.
Yes, sir.
I don't know. Yeah. What is that? Yeah. I don't know how to minimize it. Right. Yes. See here, the one thing that we gave you, I will come to that later. There are two types of problems here. Are you able to see the screen? Are you seeing the screen?
Yes, yes.
Yes.
Yes, sir.
See, vendor A, vendor B, vendor C. I have got the transaction time about how many 120 data. 120 data. Count is 120. It is given, no? 120 data is given here. Right? I want to find out which vendor is best. Which vendor is best. I run this ANOVA test. Then I'll get a p-value. And that p-value is here. What is the p-value here?
0.10.
1.3.
1.3.
It is less than 0.05 or greater than 0.05?
Greater than.
Greater than
Greater
0.5.
Great.
1 second, yeah. How to fix it, yeah? How to fix this? Yeah. Sure, Prabha. Very good. Yes. Please note 1.39 E minus 35. That means 1.39 into 10 to the power of minus 35. That means 1.39 divided by 1 followed by 0, 0, 0, 0, 39 times, 35 times. Therefore, it is very, 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 very close to 0. Clear? Understood? Yes or no?
No, sir.
No. Please note 1.39 capital E minus 35. Understood?
Yes, sir.
This is nothing but 1.3 is equal to 1.3 divided by 1, 0, 0, 0, 0, 35 times you put 0. That is what it is. Clear?
Okay.
Right? That means you are dividing by a very great value, e power 35. Right?
See, 10 power minus 1 is 1 by 10.
It
10
is
power
10
minus
power
2
minus
is 1 by
35.
100. 10 power minus 3 is 1 by 1000. What is 1 by 1000? 0.001, isn't it?
Yes.
One, yes, yes or no?
Yes.
Milli.
Now tell
Yes,
me
sir.
what is 10 power minus 35? 1 by 1 followed by 35 0. Sir is saying it is close to 0, isn't it? All that we
Yes.
want to know is whether it is less than 0.05 or more than 0.05. 10 to the
Less
power
than
minus
0.05.
35 is less than 0.05. That's all.
Less than minus.
Okay, understood? Clear?
Yes.
Yeah.
Yes, sir.
So even this you did not know because computer will do it by themselves, right? See, it is rejecting the null because P is close to 0, therefore it is rejecting the null, right? Understood? Clear? How will you do this? I will take you another problem. Lab. laboratory report. What is it? Laboratory reports. So when people come for for doing a test, and after conducting the test, a report has to be given. And sometimes it takes 1 day, sometimes it takes 3 hours, 6 hours, like that. No, how fast you should do it. If you don't give it very fast, if you take 2-3 days, then what will happen? They will lose interest. They will no more be your brand ambassadors. They will no more make references. Therefore, hospitals have a need for making this report time very quick. That is transaction time, right? Turnaround time, they call it TAT, turnaround time. So on this lab 1, lab 2, lab 3, lab 4, they have got 4 laboratories, and they are finding out which laboratory is good or which laboratory needs to be improved upon, or all the laboratories are performing same way, it is okay. Therefore, what we do is we are comparing 4 laboratories, and the transaction times are given here. You can see that 120 transaction time taken here. You can see here up to 120, you can see here. Right? See, up to 120 data is there. So this data, they are using it. Now, based on that, what is the p-value? We'll see this. P-value is coming here. Can you see what is the p-value? P-value is less than 0 or more than 0? Is there less than 0.05 or more than 0.05?
Less.
Less than.
Less than 0.05, because e power minus 57.
57.
If it is plus 57, it is much, much greater. It will not be, right? So e power 10 power, it is actually e means 10. 10 power minus 57. 10 power means capital E, right? So it is very less. Therefore, we reject the null, right? So what we will do is, I will take you to the how to do this. I'm going to explain to you. Right. I'll take this data, Control C, and then copy here. And just change the data. Here, I'm deleting this. I'm just entering the data. Control C. I'm making it Control V. Is it clear? I have taken a fresh data. Okay, ma? Say yes or no, yeah?
Okay, okay, sir.
Now,
Okay.
what I will do is I'll just delete everything. Right? Okay. Right. I'm going to go there, data. Data means then data analysis will come. If the data analysis is not coming, then what you should do is you go to file, go to option, and then here add-ins, and then here there is a Excel add-ins, clear here, go, and then you will see here analysis tool pack. You must click this checkbox, then data analysis will automatically come. Right? I will remove this, then data analysis will not come. See here. See here, I click data. There is no data analysis coming. Are you seeing?
Yes, sir.
Now I'm going to bring this data analysis back. So what I will do is I'll go to file, options, and then here add-ins, here Excel add-ins go to, and then analysis tool pack. I'm clicking. Don't click any other things. No, it will take more storage. I'll click OK. Now it has data analysis has come. Right? Now I'm clicking data analysis. Right? When I click data analysis, this particular pop-up comes. There you can see here ANOVA single factor. I click this. Understood?
Yes, sir.
Yes, sir.
Now I say OK. Again, another pop-up will come. I have to give the input range. What is the input range? I'll click this upward arrow, and then it will bring here. I can go and select here. I'll go to the A1 cell and right shift click and selecting all the 4 columns, and then control shift down. I'm clicking. All the 120 cells are selected. A1 to B121 is selected. So I'm convinced. Click OK. The grouped by columns, because each column represents one group. This is what somebody was mentioning it as label or variable. Please note this is group or column or field, whatever. And then labels in the first row, because first row tells lab 1, lab 2, lab 3, lab 4. So titles there. Alpha is 0.05. This also you can change. And then output range, I want my output to be in this cell. I will select here. I want this on G1 cell. Directly you can click there, or I include G1 cell. See here, G1 is selected. I'll go down. Then I'll click OK. What comes the response? See here, I will make this size bigger. So this you will be able to see this, right? So ANOVA single factor, and then p-value is 2.11 e power minus 57, right? And therefore the decision is reject the null. That means there is a difference in performance among these three. Okay. Now suppose I will take this. I will give you another template here also. What I will do is, I'll take this. See here. Now, here is a vendor A, vendor B, vendor C. Now I'm just deleting, Control Shift down. I'm just deleting it. Now see here, number of counts is 8. Are you able to see this? Yes or no?
Yes, sir.
Right?
Yes.
8 numbers. Average is counting. And then p-value is 0.64.
Yes.
Greater than 0.05. So decision is fail to reject the null. I'll go back. Control is that. Right. Now, there again 0.05. What I will do is, purposely I will make this vector C as different. What I will do is Control C. I'll copy somewhere here. Where the copy? I will take a new page. Control Shift down. I'll make Control C. Then I will take a separate sheet. I have protected this. Therefore, what I will do is, I will change it. Doesn't matter. I'm going to change this for 5.1 throughout. Okay. I wanted to store the data, but it doesn't matter. I will delete the data. So I made it as 5.1. Now tell me, there is a difference between the vendors. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
So that means p-value should be low. See here, p-value has become low. 0.04. So reject the null. Previously failed to reject the null. It was now reject under Control C output. See here, I have brought back the entire data. Failed to reject the null. So likewise, you can use this template, put any data you like, and then whether find out reject the null or fail to reject the null. Everything it will do by itself. You don't have to do anything. All you need to do is understand how it is calculated. If you have time, enough time, check it up yourself whether it is doing it properly or not. But it certainly will not make any mistake. Understood? Clear?
Yes.
All you need to do is 4 groups you will see here. This is a 4 group, right? Fail to reject the null. So what I will do is here again, I will copy this. Control Shift down, Control C. I'll make it as Control V. Fail to reject. Now what I want to reject the null. Therefore, what I will make it as, I'll make this one, G1. G will make it as 2.5. And then I'll make G point 2.5, very number of data. That's all. See here, reject the null. You know which is to be rejected or which is to be accepted. Yes or no? As a HR person, what you will do? If this is the transaction time, you will select group 1 because the lowest transaction time. The rest are all equally performing. Understood? Yes or no?
Yes, sir.
Yes, sir.
I'll play this video. Probably you will be able to understand this. Once again. Yes. Hi. Today we will see ANOVA test. That is hypothesis testing for more than 2 groups. Types of mean test we will see first. types of mean test, we can show it here, visualization. When there are a group and a population, we use t-test or z-test for comparing mean. When there are two groups, we are using t-test for comparing the mean. And when there are more than two groups, group 1, group 2, group 3, and for comparing the mean, then we use ANOVA test. There are three types of data we can take, and then we will use different types of ANOVA tests. Suppose we have three groups. Groups and treatments both can be used. That is, treatment also I can refer it as group. Group 1, group 2, group 3, or treatment 1, treatment 2, treatment 3. And then I am taking readings for each treatment. And this is called ANOVA one way. And then if there are different methods in each group, then for each group there will be different methods. Method 1, method 2, method 3, and like that. Then we are taking the readings. Then we want to find out which one is the best, or are they same, right? And this is called ANOVA two-way. But in order to overcome the noise factors, what we do is we take different readings, replications, repeat the experiments, repeat the trials, I would say, right? Because the entire thing is called experiment, and each one particular test is called a trial. So reading 1, reading 2, reading 3, 3 readings for each method, right? We are using. This is called ANOVA two-way with replications. We will see one by one how to do it. See here, first we will go for ANOVA one way with 3 groups. Here is the data here, and hereafter, and you will get the result here. All you need to do is fill up the data here. I have filled up the data. What I will do is Control Shift down. I'll Control Shift down. I'll delete it. You can see here count is only 4 because there are only 4 datas are there, right? And the average is calculated and failed to reject the null, right? So what I will do is I will replace the data. You can see here 120 datas are there provided, and the result is failed to reject the null. That is, all the 3 groups are same. There is no deviation here. Suppose, for example, I will change this 5.1 only. I will copy it, right, throughout. Then we will see what happens. See here, reject the null, because this is particularly a different one. This is varying from the remaining groups. So this is how you go for one-way ANOVA test. And if there are 4 groups, do the same thing. What I will do is I'll just copy this 6.454 here. See here, and you can see here, reject the null here, because this is deviating from the others. All are not performing at the same level. So this is how you do one-way ANOVA. I hope you have understood.
Yes, sir.
Very good. Thank you very much.
All right.
Professor Gopal Shokumar.
Yes. Okay, I think all of you have learned the ANOVA, right? Let's do the same thing in Minitab. So that means Minitab and Excel both has got the capability to take care of all the calculation. You don't have to do anything. The softwares will do. So let me show you how you can use what do you call the Minitab for ANOVA. So I'm sharing my screen. So here is the Excel file. Hope all of you have this Excel file, right? See, time to time we are loading you with a lot of content. If you do not follow us carefully, then probably you may miss out a lot of things in the end. So anything we communicate, try to acknowledge, and then immediately take some action. You need to have all of this stored in a certain proper place so that whenever needed you can recall, right? So I'm just figuring out the data used by RK, which is turnaround time, right? So let me check. The transaction time is available. Here is the turnaround time data. Can you see my data now? Laboratory 1, 2, 3, 4. Laboratory 1, laboratory 2, laboratory 3, laboratory 4. Let me copy this data. You can do it with Excel also, like how RK has explained with the data analysis pack. Or you can take it to Minitab. Now I am taking it to Minitab. because here the clicks are minimal and then you get the result in the required format. All right. So stat, go to stat, go to ANOVA. Can you see one way ANOVA? What is the description? It determines whether the mean of two or more groups differ. Yeah. Determine whether the mean of two or more groups differ. So I click this. Response in one column or the response in separate column. Response in separate column. Now, where are the response? Laboratory 1 in column 7, column 8, column 9, column 10. I select all of this and then, but one important assumption is variances are equal. So I go to option. First, I make an assumption. Variances are equal because this is a prerequisite for performing ANOVA. Now, confidence level 95%. Now, there is two-sided or right-tiled or left-tiled. I make it two-sided. That means if any one of the laboratory is significantly taking more turnaround time, I want to know. If any one of the laboratory is taking significantly lesser turnaround time, I want to know. Both, two-sided. It's a two-tiled. That means both side is sensitive. So I give OK. One more OK. That will complete your ANOVA. That will complete your ANOVA. Now it has even made an interval plot for you. Interval plot means plot of confidence interval. Can you see the confidence interval for laboratory 1 here in the shape of I? The average turnaround time consumed by laboratory 1 is 178 minutes for a particular test. For the same test, laboratory 2 is taking a time of how much? 178.903. More or less same? More or less same?
Yes.
Here, significantly higher time is consumed by laboratory 3. Am I right? Why do I now say significantly higher? Because this average is seen outside the confidence interval or confidence limit of all the other laboratory. Can you see that? Confidence, what is this line? Horizontal line.
That is significant.
Line of significance.
We call them as upper confidence limit. This is lower confidence limit. Yes, your answer is also correct. But you have to understand the context, right? It is better here to call it as upper confidence limit. And now this average is completely away from the confidence limits of all the other laboratories. So now I can confidently say the laboratory 3 consumes a significantly higher turnaround time than any other laboratory. Now I will take some action. Do you understand? One more prediction is also possible. Laboratory 4 consumes significantly lower turnaround time. I will learn something from here and try to make it part of my process so that all the other laboratory also can come in this interval. Do you understand? So this is, see, the confidence limits are helping you to understand the significance in your study. Clear? Now, visually we have understood. Visually we have understood how to predict the significance. Now there is also a statistical tool. What is that statistical tool which can help you to understand the significance?
P-value.
P-value. Look at the P-value. 0.00000. Close to 0. Many times even, it is not able to correct, get the accurate value. It is rounded. RK was saying 10 to the power of minus 35 and all. Something like that. P-value 0 means, my question now is it less than 0.05 or more than 0.05?
Less than around this.
Less than 0.05 means the observation is significant. You can make changes. You can believe in your experiment. That is the conclusion. Do you understand? You can believe in your experiment. If it is more than 0.05, we don't believe in the experiment. Am I right? Experiment might show some difference. know that the risk is lesser than 5%. Am I right or not? If you want to invest your money, you always wanted to be sure that the risk is minimal. Am I correct or not? So we have predefined the risk. Permissible risk is 5%. So now that p-value is less than 0.05, look here, the null hypothesis, alternate hypothesis, significance level, the rule of the game, and the beliefs are declared. And now p-value is less than 0.05. Since p-value is less than 0.05, it is now worth or correct to refer to the data. Now refer to the data. Which is the laboratory consuming more turnaround time? Look at the data here. Lab 1, 2, 3, 4. Which is the lab consuming more turnaround time?
Lab 3.
Lab 3. This conclusion can be correct simply because you have got a p-value of lesser than 0.0. Which is the laboratory that takes more turnaround time? More turnaround time is laboratory 3. Less turnaround time is laboratory 4. But if I ask you, will you be able to differentiate lab 1 and 2?
No, sir. Both are within the confidence level, sir.
Here, that's why you are seeing them overlapping. Can you see the confidence interval, the vertical line overlapping? Can you see that? If I place this I bar over the other, you can see a lot of overlapping. That overlapping is the region of you making wrong decision. If that is too much, it is better not to use that information. You leave it. It is not saying that it is insignificant. All of you understand, but there is a difference. Here the value is 178.9. 0.90. Here 178.3. There is a difference mathematically, but there is no difference statistically. Do you understand now? Mathematically, there is a difference, but statistically, there is no difference. That's all about a test of averages as of now. Definitely, you have to deep dive. Hereafter, tell me, will you be able to use this knowledge, use this tool in your practical life? Come on.
Lot of complications are there, sir.
Yeah. So this is what we mastered right now is test of averages. In my opinion, 90% of the scenario is test of average only. Can you tell me some scenario where you see that this tool will be helpful in your workplace? Can you tell me one scenario so that
On-time supply from different suppliers, sir.
wow, great. Whether the delivery is happening on time with respect to the different suppliers. Very good. Great. So that is how many suppliers? If there are 2 suppliers, tell me what will be the hypothesis testing you will use?
2 sample t-test.
Very good. If there are 5 suppliers you are dealing.
No.
Very good. And can you tell me a scenario where you will use 1 sample G-test?
Standard deviation must be known, sir.
The
Okay.
Population deviation.
Okay. Can you tell me a real-time scenario when any point of time have you ever know the value of the population standard deviation? Have you ever used population standard deviation in any calculation so far in your career? Did your company give such information? The company has not shared, right?
No, not yet. No, sir.
That means you didn't had an opportunity to perform 1 sample Z test so far. Suppose if I ask you to work on a project in Vision Excellence, right? Let me give a scenario. I want you to run a digital marketing campaign. I want you to run or improve our existing digital marketing campaign. Some of you might be an expert in digital marketing, isn't it? Right? So, or you can always have a subject matter expert with you. Now the challenge is you have to improve our digital marketing campaign. Our cost per conversion has to go down. That is the goal. That is the goal, cost per conversion. I am ready to share you what is the average cost per conversion so far we have paid. Do you understand? What is the average cost per conversion so far we are paying? I am ready to share with you. Now tell me, what is the hypothesis testing you will now perform to prove that your campaign can give a significantly better conversion? What is Y variable here? What is X variable here? What is the scenario now? Which kind of hypothesis testing will come into picture now? I am telling you right now our cost per, yes.
If we employ 2 or more methods to do our digital campaign, it will be more samples, no, sir?
No. See,
we are giving internet ads.
First of all, you should understand the Y variable. What is Y variable here? What is our metric of interest?
Conversion.
Number of conversions. Number of conversion.
Per conversion. Cost per conversion.
Cost per conversion.
Now, what is this data type? Cost per conversion. Is it continuous or discrete?
Continuous.
Now you
One sample
understood.
t-test you will use, sir.
Very good. Now you understood. It is what you call it is cost per conversion. Is why a continuous data, right? And we are talking about average cost per conversion, right? So last 5 years cost per conversion, every single month data is available. I am ready to share the complete data with you. Every month, what is our conversion cost? Conversion cost per conversion is, let's say, 5,000 rupees. I want to bring it lower. Now you have come up with another campaign. You have made a lot of changes in the campaign. Maybe the content, maybe the whatever it is, the script, the image, the targeting. There are a lot of things you have done. Now you are actually comparing your campaign with the campaign which we are already running. Am I right? And so far, whatever is the result, I am ready to share with you. Right? So now there are two campaigns you are comparing. Straight away, it is two sample t-test. It is two sample t-test, right? One campaign against another campaign. But at the same time, if I say that my average conversion rate is, let's say, 5,000 rupees right now, and with the standard deviation of some value, standard deviation of 300 rupees. Do you understand? When I give extra standard deviation, what does it mean? My conversion rate is not always 5,000 exactly. It is 5,000 plus or minus. And how much it vary, that information also I am sharing you. It is plus or minus, I am saying you 300 rupees. Do you understand? Now, what is the 300 rupees? Population
standard deviation.
Population standard.
Now, which is the hypothesis testing coming into picture?
T-test.
G-test.
Z-test.
One sample G-test. You are comparing your campaign characteristics against the population campaign characteristics.
Yes.
Right? The population campaign characteristics is 5,000 rupees per conversion with the standard deviation of 300. Since I gave the standard deviation also, you are going for one sample G-test. If I don't want to give you this much information, I will only tell you, hey, you have to get me a campaign which can give me a conversion rate much lower than 5,000 rupees. And you wanted to prove. Now the hypothesis testing is one sample. Because I am hiding my standard deviation. I don't want to share with you, maybe confidentiality. Because if the average is shared along with the standard deviation, it is as good as sharing the data, which normally companies don't want, isn't it? So that is why two scenarios, standard deviation known, standard deviation unknown. If standard deviation is unknown, you will try to understand the standard deviation with the sample data. Because sample data also can be used for calculating standard deviation.
Correct.
Population standard deviation is always given a symbol sigma. Whenever you see sigma, that is population standard deviation. Sample standard deviation should be given a symbol capital S. S is different, sigma is different. Sigma means population standard deviation. S means
LT of
sample
sample.
standard deviation. One is population standard deviation, another one is sample standard deviation. Similarly, sample mean is given a symbol X bar. Sample mean is given a symbol X bar. Population mean is given a symbol mu. Mu and sigma are the properties of your population. We call them as characteristics, population characteristics. So what are population characteristics? Population mean, population standard deviation. What is the symbol for population mean?
Mu.
Symbol for population standard deviation?
Sigma.
Sigma. The characteristics of the population are in general called as parameters. The characteristics of the population are in general called as parameters. Most of the time we want to understand the parameter, but we never can see the population together. It is very rare. So but still we want to understand the population parameter. For that purpose only we take sample. And now the sample will also have certain properties. Sample average, sample standard deviation. They are known as statistics. They are known as statistics. But why do we calculate statistics? We want to understand the population. We calculate statistics to understand the parameters. With the help of the statistics, we predict parameters, like the cooking oil example. You only measured the fat content in the sample cooking oil, but ultimately your interest is to know the quality of the cooking oil produced by a certain company. So by studying the sample statistics, you wanted to predict on the population parameters, which is a case of inferential statistics. You are trying to understand the unknown with the help of the known statistics. Clear, all of you?
Yes, sir.
Very good. So population has got a standard deviation, which is sigma. Sample has got a standard deviation, which is capital S. Am I right? So there are two types of distribution we are talking about. One is population distribution, another one is sample distribution. All of you are clear with this?
Yes, sir.
Now I want to introduce one more distribution to all of you. Right? If you don't follow carefully, then you may get confused, right? So far, how many distribution I introduced? Two. One is population distribution. Another one is sample distribution.
Sample distribution.
See, the sampling technique is very important. If you follow the right technique, your sample distribution will resemble population distribution. Isn't it? Your sample distribution will resemble population distribution, and so sample characteristics will start approaching population characteristics. Whatever you see in the sample, that will be very close to the population characteristics. And so, no, you can take better decision. But if your sampling technique is wrong, then your sample may start giving misleading information about the parameters. All right? Do you want to minimize this? Yes or no?
Yes,
do you want
sir.
to get misleaded, or do you want to get the deviation minimized?
Minimized.
So don't take individual samples. Don't take individual samples. Take samples in a group. Do you understand what I'm speaking? If you are a quality manager or if you are a professional, you are doing some inspection or you are taking some samples, never take one sample separate alone. Always you should take sample in a group. Your sample size, this is called a sample size.
You mean to
This is
say,
called
say 10 units from batch 1, 10 units from
take
batch 2?
10 units together. Take 5 units together. Take
From
3
different
units
batches.
together.
From different batches.
That
Or
means
from the
I
same batch.
want you to collect sample in a group.
No,
A
but
group
sir,
of sample is known as subgroup. A group of sample is known as subgroup. And now, the advantage with collecting samples in subgroup is the chances of giving misleading information will be minimal. But how to use the data now? Imagine your subgroup size is 5. Every 1 hour you take 5 sample. Every 1 hour you take 5 sample. So in 4 hours, how many subgroup you have taken?
4 subgroups, 20 samples.
4 subgroup. And in every subgroup, what is your number of samples? 5. Totally how many data you have? 20.
20 samples.
What I want is don't use the 20 data in the as it is condition. Calculate the subgroup average for the first subgroup.
Okay.
Calculate the subgroup average for the second subgroup.
Okay.
Third subgroup, fourth subgroup. Now how many average you will have?
4.
4 average.
This is your data now. Don't use the data as it is. Because average can eliminate the bias, isn't it?
Yes.
So whatever problems you have, that will reduce to half at least by averaging your data. Now every data point itself is an average. Can you see that? Now imagine you have 20 subgroup.
Yes.
Imagine you have 20 subgroup. Now you have 20 averages.
Yes.
Now calculate average of all the averages. That is called grand average. This grand average can take you close to the population average, better than sample average, normal sample average. Agreed?
Yes.
The grand average can take you more closer to the population average than what a normal sample average can do. Understood, all of you so far? I don't know whether you people are really, understanding or not. I could only see Manimaran, Ashok, Sivasayikaran shaking their head and Udara Lakshmi madam making some noise. All others, I don't know whether you started sleeping in the morning itself because it's a good sleeping dose we are giving.
No, sir,
No,
understood.
sir, we are listening. No, sir, we are listening. This topic is entirely new, so it is a little bit difficult.
And we are taking very
listening, sir.
seriously and understand. Try to understand very clearly.
Otherwise, you cannot be, different from other professional. If you want to be different, if you want to be better, then you have to go through certain struggle.
Yes, sir.
Always the
Correct.
good comes only if you face the bad, right? So you have to. All right. So we are talking about the subgroup average. The average of the subgroup averages, which is called as grand average, can take you much closer, to your population average than what a normal sample can do. This is agreed, right?
Yes, sir.
This is known as central limit theorem.
Sorry, could you repeat that?
This is known as central limit theorem. CLT. Central limit theorem. Your sample collection, can be, your data quality can improve. Right? Central limit theorem. Now, in the example I told, 20 subgroups. So 20 subgroup averages. Can you calculate a standard deviation using these 20 average values? Do you understand my point? I want you to calculate a standard deviation with the help of 20 subgroup averages. You type 20 values in an Excel sheet. Will you be able to calculate standard deviation out of it?
Yes, sir.
Yes, sir.
Yes, sir.
This is known as standard error of mean.
Oh, okay.
This is known as standard error of mean. Understood?
Yes, divide with
So,
and average.
so now I am taking you to again Minitab screen. Now we have talked about certain things, population parameters, right? Population parameters, which are nothing but mu and sigma, right?
Yes, sir.
Then sample statistics. Sample
Bar.
statistics,
X bar.
X bar and capital S. Now, sampling statistics. What is this called? Sampling statistics. What is sampling distribution? Distribution of subgroup averages. Here the center value is X double bar and standard error of mean. What is SEM? Standard error of mean. What is standard error of mean? Standard deviation of subgroup averages. Do you understand all of this? What is our goal? Our goal is we want to predict population parameters, right? We want to predict population parameters. Am I right or not? We want to understand what is the level of quality in our products and services. For that, we take sample. Now tell me which is better. Going with sample statistics is better. Going with sampling statistics is better.
Sampling statistics.
Sampling statistics.
So please do it. This is made as a principle theory called as central limit theory.
Central limit.
That is why in your G score, we had this formula, X bar minus mu divided by standard error of mean. Now, how to calculate standard error of mean? I told you one method. What is that method? 20 subgroup average.
Standard, yes.
Calculate the standard deviation out of it.
Of all the means.
Now, you have to wait till you get 20 subgroup average. Am I right?
True.
Suppose you don't have time. There is a shortcut. There is a shortcut. What is that? You take only one subgroup. That will give you yes. Am I right? You take only one set of sample. That will give you yes. And your subgroup will have a size. Am I right?
Yes.
Take a square root of n. Sample statistics divided by square root of n is an estimate of standard error of mean. When can you do this? When can you order food from Swiggy or Zomato?
Less time to, when we don't have time to cook.
Only when you don't have food in your house. Similarly, when you don't have time to collect data in the way I suggested, you use this shortcut. But for the same scenario, the better idea is instead of using S, you use sigma. That will be much better. Do you now understand? Do you understand three routes for knowing the standard error of mean? First route, the perfect route. You yourself collect data, good number of subgroup averages, and calculate a standard deviation out of it. That is known as standard error of mean. All of you are with me so far?
Yes, sir.
Second method, use the sample standard deviation and divide it by square root of n. But third method, which is comparatively better than the second method, is use the population standard deviation divided by square root of n. But you can use the third method only when population standard deviation is known to you. Am I correct?
Correct.
Yes, sir.
All right. So now listen to me very carefully. If the population distribution is normal, population distribution, bell curve, histogram is normal. Sample distribution may or may not be normal. Am I right? Because I know, I already told you, the quality of the sampling, if you don't know how to take sample, then you may not be able to get the same distribution, isn't it? Your sample may not resemble population.
Yes.
But if you take the sample very carefully, then whatever you see in the sample, the same thing is applicable to population also. But now coming here, sampling distribution. Is always normal. Important property of sampling distribution is it will be always normal. Only one condition. Subgroup size, or sometimes people call it sample size, must be sufficient. Do you understand the meaning of it? Sample size must be sufficient. And sample size for the sampling distribution is always from 2 to 25 maximum, that's all. 2 to 25. Do you understand what I'm telling? Every time you take a sample, how many samples you need to take? Minimum to maximum 25. Definitely within this range, your sampling distribution will start resembling the bell curve. Because all our formulas and predictions are based on the bell curve. Am I right?
Yes.
So your predictions cannot go wrong easily if you prefer to work with the sampling distribution. Whenever possible, prefer to work with sampling distribution. Then you take decision out of it. Then you make predictions out of it. That can help you much better than working with any other distribution. Right? If the population is normal, sampling distribution can help you to predict. If population is not normal, then also sampling distribution can help you to predict well. This is known as central limit theorem. So what central limit theorem is telling? The distribution of sample averages will be a normal distribution provided the sample size is sufficient. Clear? Now I have taught you a beautiful concept using which you can solve all problems in the world only by learning a single distribution, which is known as normal distribution. Any scenario, any company, any product, any characteristics. I don't know how the characteristics will vary, whether it follow normal or follow binomial or follow Poisson or follow some other distribution. Many distributions are available, isn't it? I can show you in Minitab. See how many distributions are available. Graph, probability distribution plot, right? And now view probability. Okay. And now I have to choose the distribution. See how many distribution available. Can you read it? Beta, binomial, Cauchy distribution, chi-square distribution, discrete distribution. Do you want to master all of this?
Geometry, hypergeometry, integer, largest extreme value.
Yeah, it is difficult. So it is better to work with sampling distribution. Whatever be the distribution that the population is following, you don't worry. You try to control your sample average. If you control the sample average, you are actually controlling population average. Am I correct?
Yes.
If you control the sample standard deviation, you are actually controlling population standard deviation.
Population.
If something is working properly in Earth, yes, definitely that will work in the same manner in Moon also. That's how Chandrayaan 3 is functioning now. Isn't it? We have studied in Earth first. It worked well. Now it is doing the same thing in Moon. Similarly, if you can control the sample average, sample standard deviation, it simply means you are controlling your population mean, population average. So be rest assured, your population will definitely give a pleasant experience to all your customers. Because you are monitoring what? Sample average, subgroup average, isn't it? Okay, so I think you now understood very clearly. Now I want to take you to the next topic. Shall we? Polama.
Yes. Oh,
All right. You know what is the next topic? We know which is the root cause, right? Root cause validation we have learned. Now the next information I want to know is what is the relationship of my each of the root cause with my output variable, right? Imagine you all know your blood sugar level. Your blood sugar level depends on certain X factor. Can you tell me what are those X factors?
Proper diet.
Your calorie consumption, right? We have to make it measurable. Your calorie consumption.
Exercise timing. Exercise timing.
I mean the number of kilometers you walk or number of steps you take. Some way you have to measure it, right? So the number of kilometers you walk and number of hours you sleep. There can be many other factors, so many factors. But you know that these three factors are significant. Am I right? These three are significant. And now for your sugar level, out of the three significant factor, do you think you are mishandling all the three? You are not sleeping well, you are not controlling the calories, or you are not controlling the exercising. Do you think there is a lot of variation you maintain with respect to all the three? Then all the three are root causes for you. Am I correct? If you have good control over sleeping, every day you perfectly sleep for 8 to 10 hours, go to the bed early, and then you wake up early, then you are handling it well, isn't it? Even though the factor is really a significant factor, but it is under good control. It's not a root cause currently. But there are two other factors which are root causes. One is the calorie consumption. The other one is the walking, right? The walking, the kilometers or meters you walk every day. There can be other factors also, because I'm not a competent person to talk about all the factors. I'm only talking about what I know. There can be other factors like what kind of food you eat, isn't it? That is also important. So we are not discussing all of those. Only these two. The amount of calories. Now tell me, you want to control your sugar level. Now, in order to control the sugar level, what should you do? Do you start consuming more calories, or do you start reducing your calories?
reduce the calories.
Reduce the calories.
That means, how are you saying this? You know the relationship, right? More the calories, more may be the sugar level. That is your understanding.
Yes. Yes.
This is called a relationship, direct relationship, positive relationship. Increasing the calories can directly increase your blood sugar level. Just because you know the relationship, you are suggesting a solution, isn't it? What is the solution? Reduce the calories, isn't it? All of you are with me?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Now in the first example, we understood a positive relationship. Now the exercising. Let's say every day you walk about 10,000 steps, corresponding to some kilometers or meters. Now you keep increasing the number of steps. What might happen to the sugar level?
Reduce.
If I increase my number of steps, let's say currently I am walking only 1,000 steps a day. I'm gradually increasing it to 1,500 and then 2,000, 2,500, 3,000. Now I'm slowly changing my lifestyle. As I keep on increasing the number of steps that I do every single day, what is my expectation? My sugar level
Gradually reduce.
will come down.
Yes.
Will come down or go up?
Come down.
It will come down. It will come down on one condition if calorie is not increased.
Yeah. We will come to that. We'll come to that, right? That is another concept we will be discussing next week. We are now studying only factors one at a time. While studying the steps, we are not bothered about calories. While studying about the calories, we are not bothered about the steps. But actually, we are wrong here. We'll tell you that next week. We are wrong here, right? So the number of steps I take while taking more calories can lead to a different effect. I don't know, right? That we will talk tomorrow next week. So when I increase the steps, my sugar level is coming down. What kind of relationship it is? Direct, I mean positive or negative?
Positive.
Positive.
When I increase the steps, sugar level is going down. This is called a negative relationship. Increasing X decreases Y.
Tablet.
See, result is positive. It doesn't mean that the mathematical relationship is positive. Result is good for you. I agree. But what is the mathematical relationship? Increasing the X is decreasing the Y, isn't it?
Yes.
This is what we call it negative relationship. But increasing X, if it increases Y also, we call it positive relationship. Do you think knowing the relationship is required to think about a solution to a problem?
Yes.
Yes.
If you don't know the relationship, but you are still invited for a brainstorming session to talk about the solution, are you really a person fit enough to talk about the solution?
No.
Definitely no. Better avoid stepping inside the brainstorming hall if you don't have this information. This is the mistake we do most of the time and end up, seeing unexpected results with with some gut feeling or with some trial and error way. We suggest something, but then it will finally produce adverse effect. Yes or no? If you want to minimize that, before proceeding to the improve phase, you have one more responsibility to understand the relationship between X and Y. You should at least know whether the relationship is positive or negative. Clear, all of you?
Yes, sir.
So that is why you must study this correlation and regression analysis. Even before doing the correlation and regression analysis, I suggest you to understand the scatter diagram. You all know scatter diagram, right? Which is one of the 7 basic quality control tool. Scatter diagram, you plot a scatter diagram, then go to correlation and regression. Now look at the scatter diagram in my screen. You are seeing a scatter diagram. What is scatter diagram? It is a graph showing the relationship between two continuous variables. One is known as X variable, we call it as predictor variable. Another one is Y variable, we call it as response variable. Always the response variable should be considered as Y variable. The output should be Y variable, input should be X variable. See here, I keep on increasing the X. The Y values are indicated in red color dot. Can you see that? When I keep on increasing the X, what is your understanding about Y? Y is increasing or decreasing?
Increasing.
Seems to be increasing.
I am increasing the X. I am moving right side. In Y, I am seeing that Y is continuously increasing.
Increasing.
So this is called positive relationship or positive correlation. Moreover, when I try to understand the pattern is a perfect straight line. Can you see a perfect straight line here? You can keep a scale and then connect it. All the point will fall on the line. Am I right?
Yes, sir.
That means the relationship is perfect positive correlation. Now coming here, what do you understand? The relationship is positive or negative now?
Negative.
Negative.
But still it is perfect.
Yes.
It is perfect straight line. That means relationship is linear. Perfect means linear.
Linear.
Now another one. Now I increase the X. Y is also changing, but I am not able to understand what is happening to Y. That means there is no correlation.
Okay.
But I am showing another diagram now. Now look at the graph and tell me what kind of relationship it is. Positive or
Moderate.
Positive correlation.
Moderate. You are using the word moderate and positive.
Moderate.
Earlier we told perfect. Why we told perfect?
All are in perfect straight line.
They were in a linear.
Because all the points are on the exact straight line. All the points are on the red color line. The red color line is known as regression line. Red color line is known as regression line. But this time, I am seeing my points little away from the red color line. The distance by which each of the point is away from the red color line, that is known as residual. That is known as residual.
Residual.
It's a form of error. If the points are far away from the red line, then the chances that your decisions can go wrong will be much more. If the points are close to the center line, I mean red color line, your decisions can be close to reality. All of you are with me? Right. But one thing is for sure, the relationship is not perfect. It can now be strong relationship instead of perfect. It can now be moderate relationship. It can now be weak relationship. What is your opinion? Do you think this as a weak relationship? Or do you think this as a moderate relationship? Or do you think this as a strong relationship instead of perfect? You are a little confused, right? To overcome this confusion, you can use this formula, which is called Pearson correlation coefficient. Because with eye judgment, judging the strength of the relationship is difficult. So a formula is created. The formula is designed in a way that your R can be anywhere between +1 and -1. When the R becomes +1, you can understand the relationship is perfect. When R becomes 0, you can understand there is no relationship. Right? So 0 to 1 is positive correlation. 0 to -1 is negative correlation. When R becomes 0.4 or 0 to 0.4, this is known as weak relationship or weak correlation. 0.4 to 0.7, moderate correlation. 0.7 to 1, strong correlation. More than 0.9, very strong. Now you look at the diagram and tell me, are you still able to find out? I will show you the R value for this now, right? What is the R value?
0.97.
Okay, now tell me, what is the relation you are seeing now?
Strong,
Very
positive,
strong.
Very strong,
Positive.
linear relationship. You are able to use all the word, right? Very strong, positive, and linear. Why do you say linear? Because it looks like a
Almost
straight line.
close to.
Almost straight line.
It looks like a straight line. Right? Sometimes, sometimes instead of a line, you may see a curve. Curve means behavior is dynamic. Linear means somewhat constant, isn't it? Somewhat constant. As I keep on increasing the x, I see keep on y increasing. Sometimes what happens, your y will increase to a certain level. Afterwards, it will start down, decreasing. That is a case of non-linear relationship. Now tell me, this scatter diagram, what kind of relationship you are seeing?
Positive correlation.
Positive linear relationship. Strong positive linear relationship.
Very good. Now you understood. Strong, positive, linear, or you can even say very strong. Now,
Negative.
Very strong, negative, weak.
Very good. Very good. You are now understanding a lot. Now, what is the relationship here?
Moderate positive.
Moderate positive.
Weak.
Can you see the R value here? Weak actually it is. Weak, positive, linear. Here?
Negative.
Weak negative linear.
Weak negative correlation. And here?
Random.
Scattered, completely scattered. That means no correlation.
No correlation.
Correlation.
But here?
Dynamic correlation.
Dynamic motion.
We call it
Negative
non-linear. We call it non-linear, right? Non-linear, or you can call it quadratic, because it looks like a parabola. We all have studied parabola in our school, right? All of you studied the equation of straight line in our mathematics. What is the equation formula for straight line? Y equal to mx plus c. You remember? Y equal to mx plus c, right? That is straight line. But here it is curve. The curve is known as parabola. So first case, no correlation, no relationship. But second case, no correlation. Correlation means linear relation. But there is non-linear relation, which is known as parabolic relation here. All right. Now let us do a small case study. See here, a person want to understand the relationship between the amount of calorie he is consuming and the way in which his body is behaving in terms of weight. You understand? Please note, calorie consumption and weight gain need not be always having the same relationship. Some people, they eat less but still become, put more weight. Some people, they eat heavy more, but then also they look like this. It varies from person to person. Lot of factors involved. Yes or no?
Yes.
So it is always good to conduct an experiment and understand the relationship. If you think you are a doctor and you give the same medicine to all the patients coming, do you think you are always giving the right treatment?
No.
For some people, your medicine can give adverse effect, isn't it? So you need to understand, right? So such an experiment we are doing here. Calorie consumption is varied gradually. The behavior of the body with respect to weight gaining is noted. When a person is consuming 1500 calories throughout a week, every single day he noticed no weight gain. Next week, look at the way the experiment is conducted. Several weeks experiment is conducted. Now he wants to understand how his body is behaving with respect to different levels of calories. So what happened? The R value is calculated. What is the R value coming out to be? 0.97. Once the R value is 0.97, what is your understanding?
Positive correlation.
Strong positive correlation. Now, I want you to calculate something known as R square. Very simple. R has to be squared. 0.97, when multiplied again with the 0.97, what will be your answer? 0.94. This has got an important information in it. First of all, the R square. R is Pearson correlation coefficient, but R square is coefficient of determination. R square is coefficient of determination. This is telling you 94% of the changes. Let us go to the data. 94% of the changes. Do you see changes in the weight gain in the first column?
Yes.
Whatever change you are seeing in the first column is due to the changes you have made in the second column. You understand?
Yes.
The changes we are seeing in the first column, at least 94% of the changes we are seeing in the first column is due to the changes we have made in the second column. That means this particular X factor is a strong influencer of your Y factor. Am I right?
Yes, correct.
Since the value is 94%, it is not only a strong influencer, the only influencer. Do you understand my language now? It is not only a strong influencer, it is the only influencer. That means it is the single root cause which is responsible for your all problems related to weight. You understand? So whenever your R square is more than 80% or 90%, that means you have reached the solution. That means you have reached the solution. You don't have to investigate further. because the major influencer is understood. Maximum R square is how much? 100% only. Now tell me, who is the major influencer in your family? You or your wife or your parents or are your children?
Hypothetical question.
Tough question. Huh?
It depends on situation.
What you are making.
Okay.
Depends on situation.
Depends on the situation. Let's say you want to go to a movie. Who is the
Wife.
major influencer?
Wife.
It's
Wife.
right. So that is what we are trying to understand. If there is a problem in the weight gain, yes, the major influencer is calories only. Right? For when we are going for the movie, the others are not influencing. Only kids are influencing. Same manner, in this particular scenario, calorie consumption is the single influencer. This you need to understand. And now you will be able to offer solution to the particular individual who is suffering with the weight gain or weight loss. Okay. Understood?
Yes, sir.
All right. Now,
Yes, sir.
yeah. Now I'm going to take you to Minitab to do the same thing with the help of Minitab. So first, I'm going to the Excel. I don't know how many of you are going to practice all of this by spending time. Then the course will start delivering results for you. If you are simply just looking at how we are doing, only we will get a lot of participants. Nothing else will happen.
I'm already doing it in Minitab as you speak.
Minitab?
As you speak, yeah, I'm already doing it in Minitab. I downloaded that version.
Very good. So you're doing it. That's what we want to see. See here, I'm just copying weight gain and calorie consumed. This I have. See, look at all the calculation. I have done it manually for you. You at least take some time and then to see what happening here. All the calculation I have explained manually. I have done it for you. And inference is written, conclusion is written. You read everything. But the easy method is taking it to Minitab, right? Let me open a new worksheet. New worksheet, and then I'm pasting it. I've pasted the data. Now, what is that I want to do first? I want to see my scatter diagram. Graph, scatter plot. Simple scatter plot. Okay. Y variable. Which is Y variable?
C1 is
Thing of weight.
X variable is C2. So after giving Y and X, I give OK. Are you able to see the scatter diagram?
Yes.
Now you see a positive trend, right?
Yes.
Positive relationship. You also see a kind of linear trend. If you also want Minitab to suggest the trend also, then you can choose trend line with regression. Third option. If you go there, Minitab will also suggest you which can be a better trend. And see here now. Minitab tells you that the relationship is linear. What is this tool right now? You are seeing scatter plot.
Scatter plot. Huh?
In order to use the scatter plot, X and Y both must be continuous. Understood?
Yes.
Very good.
Yes, sir.
Now let us proceed performing correlation analysis. Go to stat, basic stat, come to correlation. The description says, measure the strength and direction of the linear relationship between two variables. Select this. Select both factors. Pearson correlation. Give OK. Can you see 0.97? In just two, 3 clicks, you got 0.97. But you can always do it manually also. Now, very, very important is knowing your R square. What is R square? How to calculate?
Square of R.
0.97 multiplied by 0.97. 0.97 multiplied by 0.97. So the result is how much?
0.94.
0.9401. Now, very, very important inference. 94.01% of the changes observed in Y variable are due to
Calorie consumption.
the changes
X factor.
made in the X variable.
Yes.
That means what is your Y variable?
Wait.
Yeah. So now I am typing 94% of the changes observed in the weight are due to the changes made in the
Calorie
consumption. Calories consumed. Do you think this information will be very, very helpful to you?
Yes.
Yes, sir.
The 94% is confirming that this single factor is bringing all the problem. Am I right?
Yes, sir.
But please note, we are only predicting with the help of data. Yes or no?
Yes.
According to the data in my hand, this is the prediction I can do. But always your common sense is much more powerful than all the science and books, whatever you study. Do you agree with that?
Yes, sir.
Please use your common sense along with all these inferences. Don't simply argue. Even though the statistics is telling this, still you feel that, sir, there is one more reason I want to improve. I want to correct my stress level. Yes, you correct it. Nothing wrong. This is only statistics because the statistics, the quality of statistics depends on quality of the data. Am I correct? Sometimes statistics may even, completely lead you in the wrong direction also. That is also possible. You can't say, sir, I have statistics, R square is this much, so this should happen, but it is not happening. That means you don't have common sense. You are believing the statistics to the extent that you don't even want to apply your common sense. That is not fair. That is not correct. Am I correct or not?
Right. Sir, here I want to cite one example. If we apply the same to in the stock markets also, we don't invest in car and petrol at once. The correlation is positive. Suppose the sales go down on the petrol prices go down, both the stock prices would come down. So here the common sense of not applying the coefficient positive is done with mutual fund companies. So
Correct. Very true. I can give another very, very easy example, right? Like imagine there is a rainfall happening. How do we measure rainfall? In centimeters. The rainfall day by day increases. Now there is a lot of rush in all the hospitals in the city, right? And the majority of the cases are suffered with malaria. Now I do the statistical analysis between rainfall and malaria cases. As the rainfall keeps on increasing, malaria cases also increasing. Now I am making a conclusion. More the rainfall, more will be the malaria cases, which means the rainfall is causing malaria. Now I have lost my common sense. Isn't it? Rainfall is not causing malaria. Then what is causing malaria?
Increase in mosquitoes.
Water stagnation.
Mosquitoes.
Mosquitoes are causing malaria because of the rainfall. Mosquitoes are increased.
Because of the rainfall, mosquitoes reproduce more, and as a result, more malaria cases are getting reported. And I didn't realize this. I didn't, tabulate my data properly. I only tabulated rainfall and then malaria cases. I forgot to include the another factor, which is the reproduction rate of mosquitoes. Now I am missing out on my common sense. Can you see that? So it is finally, it is you who is going to use all the tools in an intelligent manner. Don't rely too much on the tools. Tools are to help you. But the tool which is more powerful than anything else is your own intelligence, your own common sense. That also you must use. All right. So now this is the meaning. Now let us proceed to regression. What is regression? Regression is nothing but A mathematical equation. A mathematical equation. Udra Lakshmi madam, your background is too noisy. Can you please see to that it is controlled or mute yourself? Okay. Mathematical equation describing the relationship between your x variables and y variable. Between your x variables and y variable. If there is only one x variable you are studying, then your regression is simple linear regression. Understand? There is only one x factor, like calorie consumption and then weight gain. Only one x factor. What is the relation? What is the regression called? Simple linear regression. If you have more than one x factor, then your regression is multiple linear regression. All of you are with me? Now.
Yes.
Now imagine you want to go to your, go to a particular location. Let's say a particular shopping mall in your city. First time you are going. So you don't know how to reach there. I mean, you don't know how much time it will take. Now, what do we do? What do we do under such situation? We immediately open
Google Maps.
Google Maps. Now, Google Map will tell you the amount, the time you will require to reach the place, isn't it?
Yes.
Time to reach the place. I mean the travel time, or otherwise I would say travel time. Travel time to reach the place. This is x variable or y variable?
X.
Y variable. That is the
Y,
final.
Y.
Yeah.
Now, there are x variables involved. What are the x variables involved?
Traffic, time,
Vehicle.
Congestion.
Type of
vehicle,
Traffic.
type of vehicle, approach road,
Very good, very good. Traffic, one by one. Type of vehicle.
time started,
Distance.
Speed of vehicle.
Distance is
At
important or
which
not?
is going.
yes,
More
Sir,
the
yes.
distance, more time. Less the distance, less time. More traffic, more time. Less traffic, less time. Better vehicle, faster reach. Isn't it? So
Speed
relationship.
at which he is driving, that also is a
What is that?
factor.
What is that?
Speed at which the driver is driving.
Oh, speed. This is not constant. This is very dynamic factor, isn't it?
Yes, sir.
Google Map will continuously study that and adjust the timing as you progress. That's why. These four factors, do you think are enough to judge correctly?
Sufficiently.
Very good. So this is your x1. This is your x2. This is your x3. And finally, this is your x4. Google Map exactly uses all of these x factor. All the four are significant factor. Right? Do you think your shirt color is an important factor to decide on the distance? That is insignificant. You can wear any dress you want. The amount of food you consume or you ate, that's insignificant. These are all insignificant factor. This is what we understood in hypothesis testing. Clear? The app developer clearly know these four factors are significant factor. Every single time traffic is more, they have seen a car reaching late or taking more time, isn't it? The average time consumed by vehicle while traveling in a heavy traffic was high, isn't it? So traffic is significant to travel time. The conclusion. Low traffic, the average time taken is some value. But heavy traffic, the average time is more value. And now the distance between the two averages is found to be significant. This is a two sample t-test they have done. They realized traffic is a significant factor. So they designed the app to understand the traffic condition before giving you an answer. Yes or no? That's why the Google
Yes,
Map,
sir.
working better. It's preferred than anyone else, anything else. We all immediately open the Google Map because it takes into account the right factors. And Google Map also knows the relationship of each of the factor with your output. And so it is predicting better. Yes or no?
Yes, sir.
Yes, sir.
That means
Yes, sir.
a regression equation is running in the back end. Yes, correct. A mathematical equation is helping Google Map to find out the distance, find out the time. Similarly, type of vehicle. If you change from walking to two-wheeler to car to a public transportation, there will be corresponding change in the time consumed. Yes or no?
Yes, sir.
So Google will collect that information also from you. You have to declare that also. It will substitute that value in the equation and find out a y variable. Now the third one, distance, that Google itself knows it, but that is also an input. Yes or no? Even though you are not giving, Google itself, will calculate the distance. And if the more the kilometers, more will be the time. Less the kilometer, less will be the time. Now, finally, your instantaneous speed. Sometimes you might have noticed
Disturbance.
when you drive faster, automatically the time 2 minutes will come down. So this is the equation. See here, now you have to write an equation. Y equal to ax1 plus bx2 plus cx3 plus dx4 plus a constant e. Can you see the regression equation, all of you? I am only using x1, x2, x3, x4. That's why it is known as linear. If I use x1 square, then it becomes quadratic, non-linear. So I should know whether the relationship is linear or non-linear. How do I know? You look at your scatter diagram, isn't it? Do you now understand another purpose of scatter diagram? If I plot a scatter diagram, I see a line, then it is linear. I see a curve, then it is non-linear. Then I will ask another question, what kind of curve it is? Is it a parabola or is it cubic? Parabola means x square. Cubic means x cube. Something like that. Let us not worry about the advanced regression. We will be limiting our thinking to linear only. Next stage you will understand, right? So see here, now the x1, x2, x3, x4, they're all known as predictor variables. Y is the single response variable. And A is known as regression coefficient. What is A? Regression coefficient. A, even B, C, D. All of them are known as regression coefficient. If A is positive, please note, if the A is positive, it means relationship is positive. All of you know the meaning of it, right? Will you be able to understand the relationship just by seeing the regression equation? What is that you should look at to understand the relationship? You should look at regression coefficient. Let me make a change here. The plus I am changing into minus. Now tell me, what kind of relationship x2 has got with your y? I have changed the equation. Can you see here? I have changed the plus to minus. Now, what is the relationship between x2 and y? Can you tell me?
Negative.
Yeah, now it is negative. So, how do you understand this? By looking at the signature of the regression coefficient. Am I right?
Yes.
Now, in our example, traffic has positive relationship. More traffic, more time, positive relationship. More distance, more time. More the speed, lesser the time. Am I right?
Yes.
So
Negative.
I'll make the change accordingly. Here it is plus, here it will be minus. Am I right? Am I doing correctly?
Yes.
Signature wise, I am putting plus for the factors, but only for the speed, I want to put minus because I know more the speed, less the time. Less the speed, more the time. That's why the minus and plus is changing. Now, signature is helping us. Do you think the magnitude of the coefficients can also help you?
Yes, majorly.
Yes, sir.
The answer is yes. Yes, it will help. Imagine the regression coefficient A equal to 0.2. A equal to 0.2. It means if I increase the particular x by 1 unit, y variable is expected to increase by 0.2 units on an average. You understand what I have written here?
Yes, sir. If the distance itself changes, maybe if not 10 kilometers, if it goes to 11 kilometers, then maybe again the time will change.
Exactly. Ultimately, in your project, you want to improve your y, isn't it? That is your goal.
Correct, sir.
That is your goal. You want to improve your y, yes or no?
Yes, sir.
So how can I improve? By changing the x.
X.
So how can I change the x? Which x I should change? In which direction I should change? How much I should change? Do you get answer for all these questions now?
Yes, sir.
Yes, sir.
Now you enter the brainstorming hall. Now you go to the hall where people are thinking about the solution. People are talking about the solution. Who can talk better? Who can talk better now?
One who understands the relationship.
The person who has the regression equation in his hand, he can talk to the point much, much better, much, much clearer than anyone else. Am I correct?
Yes.
You know each and every piece of information. You know which are the significant factors. Please answer me all the questions one by one. Do you know all the significant factors?
Yes, sir.
Yes, sir.
And do you also know the kind of relationship each significant factor has got with your y variable?
Yes.
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 Do you also know what will happen if you change a particular x by a particular amount?
Yes.
Yes.
What else you want to solve your problem? You don't need anything else, isn't it?
Nothing. Nothing.
That's all. Only thing is, in addition to using all the tools, you should have also used your common sense. That is one important thing. All right. So that's it. So this is it's called factor sufficiency. You can stop your analysis the moment you see R square above 80%. The moment you see your R square above 80%, you can stop your analysis and you can move to improve phase. Agreed? Understood?
Yes, sir.
Now let me show you how you can do the regression analysis in Minitab for X and Y. So go to stat, go to regression, go to fitted line plot. Go to stat, regression, fitted line plot. Now Y variable, which is your Y variable? Weight gain. X variable, calorie consumption. Now which one I should choose? Linear, quadratic or cubic?
Linear.
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 Give OK. Now scatter diagram is drawn. Can you see your regression equation?
Go to
Can you see
analyze
your
phase.
same? Now weight gain Y equal to 0.4631 multiplied by X minus a constant. Now, what is the regression coefficient here? Can you tell me? Which is called as regression coefficient here?
0.46.
Ah. Can you tell me how is it helping you? 0.4631, one of you?
It's average.
For one unit of weight gained, it will be 0.4 increase of calories. 0.4 units of calories increase.
Very good. Correct only. But can somebody again reframe it with a complete correct statement? But his point is correct.
So this 0.46 calories intake will be give an impact on weight gain. That no.
No. Anyone else? You can try.
0.46 calories helps for 1 kilo weight gain.
No.
Every increase of 0.46 calories.
Wait. We'll go to the learning. Same Excel. See here, if I increase particular x by 1 unit, y variable is expected to increase by 0.2 unit on an average. Am I right? Shall we use this language?
Yes.
We'll use this language, right? I just
to reduce
wait.
the weight.
Wait. You will come. So if I increase the x, what is your x?
Calorie.
Okay. If I increase, I'm saying calories, right? Calories by 1 unit. Y variable is nothing but
weight gain.
Weight is expected to gain by, what is the number you have seen?
0.40.
Unit is grams. Do you find this language helpful now?
Yes.
Yes.
If you want to increase 4 kg, what are you supposed to do? You have an answer there.
You have to increase one unit of calories.
You convert the grams into kilograms and accordingly find out the calories, right? 10 calories if I increase, probably I get 4 grams weight. 100 calories I increase, I get 46 grams.
1000 to 4 kgs.
1000 calories, I get 460 grams.
Kilograms should be the...
Probably, right? Use that simple, mathematics. Now you got a beautiful solution for your problem. And this solution is based on data. We are not a domain expertise. Please note, all of you, we are not a domain expert. We are not the right person to talk about weight and calories. We never studied this. But still, we are able to talk much better than even a domain expert. Because we know as a statistician, these kind of parameters will vary from person to person. Isn't it? Even though we studied several things, scientific learning from a lot of books, even then, finally what your data is revealing, that is only applicable for a particular scenario. Isn't it? All right? The scientific principles are correct, but subject to conditions you might have studied. But the same condition may not exist in your workplace. So you have to do the experiment and then generate the data. Based on the data, you judge. Hope all of you understood the application of correlation and regression. Am I right?
Yes, sir.
Yes, sir.
Feeling better or feeling further down? All right, but you have to take time, right? You have to learn again and again. First time, everything, will be a strange things for you. You can't be comfortable, the very first time. But definitely you will feel comfortable if you revisit, right? So you should have the habit of revisiting. Now, one more thing I would like to discuss. We have got 5 minutes for that, so that the afternoon session you can be fully comfortable. What is that? I want to speak to you about another important tool. What is the tool? Control chart. Control chart basically helps you to understand the variation. Understand the variation. Variation can be of two types. Variation is sometimes normal. Oh, sorry. Variation is sometimes. Oh, I touched something. Okay. It should not. So variation is sometimes normal and sometimes it is abnormal. Am I right? If it is normal, don't react. Am I right? If it is normal, don't react. But if it is abnormal, you have to react. Am I right? If the variation observed is normal, don't do anything. If you react, it will become unnecessary. If variation is abnormal, don't react, then it will be very problematic. So the normal variation is also known as random variation. If something happens randomly, don't worry. If something happens because of some because of some factor deviating, then you need to take action. So it is known as random or sometimes known as common cause variation. But the abnormal variation, this is known as special cause variation. So basically in control chart, we want to know whether the variation is due to common cause or due to special cause. If your child is every day coming late by 2 or 3 minutes, is it normal or abnormal?
Normal.
But one fine day, a child comes late by more than 2 hours. This is
Abnormal variation.
abnormal. You need to check with the teacher what happened, isn't it? You can't think, you just should not keep quiet because your child has arrived. It doesn't mean that, it's not going to become a problem later on. You have to figure out the reason and then have some control measure on it. Then only you can prevent the problem. Yes or no? If you don't do that and simply keep quiet, and it may happen again and again, and one day it can be a big threat. The same thing is possible in your workplace also. So always we want to know. And this is why, in the hospitals also, when you go to the ICU ward, there will be several patients in critical condition. Am I right? And next to every patient, there will be some graph going. Have you seen that? It's a kind of ECG.
Yep.
That is nothing but a control chart. If the nurse in the ICU ward, if she notices a big spike, what she is supposed to do? She is immediately inform the doctor, isn't it? Then the doctor will come and then check why there is a big spike. But if there is a small up and down, that is quite normal. Even if we go and sleep there, we will also have that small up and down. Yes or no? You don't have to worry about small up and down. Yes. But if a spike happens, yes, that is something special. So in order to have a clear definition, when to call the doctor and when to consider it normal, because as a nurse we should know, right? So similarly in our process, we need to know when to make changes in the process and when not to make any changes in the process. For that, the boundary line is, we have already studied it.
Control limit, lower control limit.
That's all. We very well know about control limit. What is that control limit? X bar plus or minus 3 times standard deviation, isn't it? Instead of saying X bar, I can even say center line. Center line is mostly X double bar. All of you understand the formula for the control limit? Center line plus or minus 3 times standard deviation. Whenever you see an observation outside a control limit, that should be considered special cause. Am I right? That should be considered special cause.
Special cause.
If you see the observation, if you see your statistics always inside the control limit, This is known as common cause. Nothing to worry. Am I right? If you see your statistics inside the control limit, nothing to worry. But if you see your statistics outside the control limit, there is a piece of information which is important to be understood, isn't it? It may be good, it may be bad, we don't know, but it is special. If it is bad, try to stop it. If it is good, try to multiply it. Right? We conduct the exam, one of you got 100 out of 100. Yes, we have to spend few minutes with you to understand how you got 100 out of 100, isn't it? So that we can share the secret with all the others and then everybody can get 100 out of 100. If somebody fails, now we need to understand, is it our training is ineffective or the fellow has gotten a special information, special reason? Some people sometimes, they will have their own reason and then they always want to score lower mark. Am I right? They would like to stay outside the control limit. Agreed? Understood, all of you? So ultimately, by control chart, we want to understand whether the variation is due to special cause or common cause. If it is common cause, no problem. You can continue, run the process, continue, don't do anything. But if you see a point outside the control limit, it is special cause. You have to stop the process. You have to find out the reason. You have to take action. If you fail to do that, same problem with the higher magnitude will definitely happen in the near future, right? So now the time is 1:05. I want all of you to give me another 10 minutes. Is that okay?
Okay,
Yes,
sir.
sir. Okay, sir.
Yes.
All right. So that we will finish chart and then go. So now I want to, okay, I'm sharing my complete slide. So I want to pick up data from the Excel. Can you see my Excel now? Can you see my Excel?
Not yet, sir.
Okay,
Yes,
then
sir.
I have to share my complete screen then. So I'm sharing my complete screen. You should be able to see my Excel. I'm going to collect some data here. It's not coming. Okay, let me take this, no problem. So this data is coating thickness. So coating thickness, I am taking, see here, so much data. I just copy this, 70, okay, Control C. Now I'm going to Minitab. I'm coming here. So maybe in column 5, I'm just pasting it. Can you see coating thickness? How many data I have?
Yes.
How many data I have?
75.
75.
75. Imagine this data has been collected in subgroup. In subgroup with a subgroup size of 3. In subgroup with a subgroup size of 3. So how many subgroups I have taken? 25 subgroups. 25 into 3, 75 data. Now tell me, coating thickness, is it continuous data or discrete data?
Continuous.
Now you want to go for variable chart for subgroups. Variable chart. Because there are two types of control chart. One is variable chart, another one is attribute chart. Since your data is continuous, you have to go for variable chart. If your data is discrete, you need to go for attribute chart. Now the broader classification is variable attribute. Coating thickness is a continuous variable. So we go for variable chart. Now within variable chart, there are 3 charts depending on the subgroup size. If subgroup size is equal to 1, then you need to go for a chart known as IMR chart. When subgroup size is between 2 to 8, you need to go for a chart known as X bar R chart. What is the chart you should go for? X bar R chart. If subgroup size is more than 8, then you need to go for a chart known as X bar S chart. All of you are with me so far? Now, which is the chart you should go for? What is your subgroup size?
X bar S chart.
X bar R chart.
X bar R chart, because our subgroup size is 3. We have to use X bar R chart. Let me show you how to plot X bar R chart. Go to stat, go to control chart. You have to go for variable chart for subgroup. Now, which one I should choose? X bar R. Can you see, all of you? X bar R. I select this. Now it is asking me, how is your data? My data is in single column. Now I click here. Which column is your data? Column 5. Now subgroup size. What is your subgroup size? 3. Now you have to go for X bar R option. What are the tests you want to perform? There are several tests possible. Now I want you to learn only one test. Whether a point is inside control limit or outside control limit. That is the first test you should do. Right? Like the first thing I should check as a teacher is whether all my students are inside my class or not, isn't it? All of you should be inside the class. Same manner, in your process, all your points should be inside the control limit. And control limit, what is the formula? 3 standard deviation. Can you see 3 here? Can you see 3? Here.
Yes.
Very good. So I only use the condition. See, the extra condition you can apply after having enough maturity about the process. After having enough maturity about the process. Right now, for certification, we have only one condition. You know what is the condition we are following? You just have to score 60% and above.
60%.
It is always a good idea to add additional condition. What can be an additional condition? You have to submit one project. Third condition, 100% attendance. Fourth condition, assignments. If we add all the condition, do you think so many people will come to our training?
No.
Maturity is
No.
required. Yes, very good. So that is why only one condition, right? You also in your process, please don't blindly add all the condition. No. You understand, if I apply this condition, is it making sense? If it makes sense, yes. Otherwise not. So right now, first condition only. I'll tell you how to add all the other condition probably the next week. Right now, only one condition, and then I give OK, and Minitab is doing everything for me, and it has plotted the control chart. Can you see the X bar R chart in my screen?
Yes, sir.
Now, the bottom chart, which is R chart, is very good, looking good. Can you see that?
Yes, control, everything in control.
Consistency wise, there is no problem.
Well within control limits.
Consistency wise, there is no problem. But the center value, I see very often shifting upward and shifting downward. Can you see that? Every subgroup, there is a consistent quality. But consistently good or consistently bad, I don't know. But there is consistency. Do you understand? There is consistency inside every subgroup. But whether it is a good consistency or bad consistency, I don't know. Do you understand? If you want to understand whether the consistency is good or bad, then you must look at X bar chart. Am I right?
Yes, sir.
You want to understand the consistency inside each sample, look at R chart. You want to understand the goodness or badness, you must look at X bar chart. All of you are with me?
Yes, sir.
Yes, sir.
Imagine I am conducting 3 exams. All 3 times you got the same score. Are you consistent now?
Yes.
Very good. But your score is all 3 times, only 33. Are you consistently good or consistently bad?
Consistently bad.
If all 3 times you are above 80, you are now consistently good.
Yes.
So in order to say good or bad, you should look at X bar chart. In order to say whether you are consistent, whether the quality inside the sample, every sample is consistent or not, you should look at R chart. We need both. Am I right? We need both. So R chart says, yes, there is consistency in every lot. In every lot, there is consistency. At the same time, I want every lot to only have good products. But I see a problem with the 5th lot. I see a problem with the 9th lot. I see a problem with the 10th lot. So many problems I have. That means I'm running a very, a process which is having a very low capability. Can you see that?
Beyond the limit.
Now, what to do if I see these kind of points? What should I do? Shall I feel happy and then continue running the process?
No, sir.
No.
Analyze those lots wherein the errors are occurring.
If you really want to be a responsible professional, when are you supposed to react? Can you react seeing your first red color point?
When it is abnormal.
Sir, we should calculate the CP capability indexes sort of thing now.
See, that is called capability analysis, CP/CPK. Yes, you need to calculate, but before calculating CP/CPK, you should have statistical control in your control chart. Only if all of you attend the classes, I can conduct the exam. Isn't it? If you are not attending my class, then conducting the exam has no meaning. Please don't jump to capability analysis before correcting your control chart. Isn't it? If somebody is directly writing the exam, still passing the exam, getting the certificate, do you think he has become a green belt or a black belt? No. So no need to jump. So what I want is, first correct your control chart, then conduct the capability analysis. This is the right guidance. Not many companies follow this. Isn't it? Not many companies follow this. Now there are several red color points. 1, 2, 3, 4, 5, 6, 7 red color points. Tell me, when will you react if you are running this process? Will you react by seeing the first red color point?
No.
Or will you react after seeing the second red color point?
No, first.
No, the third.
Third one. Why third? Why not the 1 and 2?
Because the first time it can be random. The first
you want to see that the problem
occurs repeatedly. Only then will we check, because first time it can be random, second time it can be a coincidence, but when it occurs for third time, you will
abnormal is one time is coming.
Wait. So you want to wait till the problem becomes a normal event. Is it so?
No, if the problem is repeatable or not.
You want to react only if the problem is repeatable. Please note.
No, actually, goes out of control, I will check whether it is a special cause. I will check whether the special cause is random.
Okay, very good. Good thinking. Good. You're all thinking in a much better manner. But I have a different opinion to share with all of you. First of all these points are not just representing one unit. You need to know that. It is not just one unit, isn't it?
They are averages.
Each and every point is a statistics. We should know that. This is a average of subgroup number 5. Inside your subgroup number 5, how many samples you had?
5 samples.
3 samples.
3 samples.
The average of the 3 is going out. That means subgroup number 5 to 6 or subgroup number 4 to 5. What is the time gap? Maybe 1 hour, or maybe 1 full shift, maybe 1 complete day. Yes or no?
Yes.
If subgroup number 5 is out of control, now there is a possibility that everything you produced from subgroup number 4 to 5, the time lapse between last sample and the current sample could have been completely wrong. Can you see that? Suppose, imagine you produced 5,000 pieces between subgroup number 4 and 5. Now all the 5,000 pieces might be wrong. Yes or no?
Yes.
So you need to know that and then take a decision. This is called common sense again. Now you don't have to wait till the second and third. Because this 5,000 pieces, you have to take a decision whether to dispatch or not. Because these 3 samples represent those 5,000 pieces. Can you see that? Do you understand, all of you? The 3 sample is a representative of the 5,000 pieces which you want to dispatch. But the representatives are not good. Will you still dispatch all the 5,000 pieces?
No, no, sir.
No.
Are you sure type 2 error will not happen? Sending the bad to market.
No, it will happen.
So you have to take action
Immediately.
immediately. Don't wait. Stop the process. Stop the dispatch. Do 100% inspection of the complete number of units between 4 and 5. Maybe 5,000 pieces, maybe 10,000 pieces, no matter. You have to demand 100% inspection. All of you, do you understand?
Yes.
After 100% inspection, you come to know how many are good, how many are bad. Now you take a decision. You dispatch all the good one. All the bad one, you do rework or you scrap it. Clear, all of you?
Yes.
You have to do the problem containment. Otherwise, what happens? Problem will go to the market. You do the problem containment and do the segregation, good and bad. Then correct the bad. If correction is not possible, completely scrap it. Then also don't proceed. Seek for the reason why it happened. Yes or no?
Sure.
Try to understand the reason. What went wrong? Why this happened during subgroup number 5? Once you are able to figure out that, then continue running. Otherwise, these kind of problems will happen very frequently. So the purpose of control chart is letting you know whether the variation is due to random cause or special cause, due to common cause or special cause. This knowledge is widely used in all business, even in sports also. Have you seen the review system nowadays?
Yes, yes.
Whether the ball has nicked on the bat or not. If there is a doubt, they immediately go for the DRS, isn't it? The replay will clearly show. A control chart also will come parallelly. Have you noticed that?
Yes, yes.
If the ball doesn't touch the bat, then the vibration of the air molecules is only due to the movement of the ball. You can see it's only a normal variation, normal vibration. But in addition to the travel of the ball, if it also hits the bat on its path, exactly at that moment, you can see a spike. So that is due to a special cause. And the special cause is without ball touching the bat, it cannot happen. By mapping the time, I can judge whether the umpire decision is correct or not. This is how the DRS system works. So the basic principle behind that is control chart. This is called Shewhart theory of variability. If something is going beyond your control limit, it can happen only with a reason. Without reason, it cannot happen. That is the belief. So this is how control chart must be used. Hope you understood how to use the control chart. Am I correct? Am I correct?
Yes, sir.
All right. That means we can now
Yes, sir.
stop here for lunch. And then we will continue.